Yes. Hey guys, how are you all this evening? Oh, YouTube's complaining about my bitrate again. It's too high, it's too low, insert an ad. Let's see if everything's working. We can see me, I think. Can we also hear me? I think so. It looks good. All my meters are displaying. It's alive! Okay, I think I've got my desk somewhat in order enough. So, for drinks tonight, I don't have anything exotic. I don't even have Fanta exotic. But I do have Coke Vanilla or, well, the regular Coke Zero. But, as we've gotten used to on this live stream, we can make it Ultra. Right? So let's make it a Coke Zero Ultra. That music must be that loud. Well, it should be toned down now. Is it still too loud? Let me make some special ultras today. Oh, not like that. Almost done with the special ultras. Let's go. Print it. Oh, I can almost reach it. Oh, there we go. Yes. Let's use the ultras to check the top camera. Okay, top camera is working. Let's focus it. There. Well, that's ultra. Well, yeah, when I don't breathe. No, when I don't speak, it does get a little bit louder, so you have some background music for, like, when I'm placing components and things like that. But it shouldn't get louder than what my speech normally is, so normally it shouldn't interfere too much. Hyper ultra. Wow, okay. Yeah, no, this is just triple ultra. Does that enhance the alcohol content? I don't actually know. Hello, Emil Bart. Welcome. Let's put all the ultra over the nutritional information. There. So now we have the Coke Zero Ultra. It doesn't want to focus anymore. Oh, there it is. Ultra Zero Sugar. It's like it sucks the sugar out of your body. Happy Friday. Well, happy Friday to you, Joshua Clark. So, cheers. What are you guys drinking? Always interested. I guess drinks are really one of those things that's a personal taste, and everyone drinks something else at any given time. As you know, I like to drink Cokes. Water. Oh, well, I guess that's a universal. Eating grapes. I guess eating grapes is like partially drinking, I guess. I don't know. Plain Coke Zero. Aw. Yours doesn't have Ultra? Aw. It's too bad. Well, I can turn it down a little bit more. And I don't want to mess with the ramping right now because that's going to be a mess. And we'll be playing with that for the next half hour. But I turn it down a little bit more. Hopefully it's less distracting. Dr. Pepper Zero. I still haven't been able to find that in the Netherlands. We'll be cracking open a Bitburger soup. Nice. Good evening there, Johnny Bergdahl. Oh, the music was perfect. It's a lot more silent than usual, actually, for me. Okay, well, I don't know. We'll just leave it like this, and let's hope it's fine. You just found out your Christmas lights are finally supported? What kind of exotic Christmas lights do you have? What will be the topic tonight? Well, You'll find out in 5 minutes. We're in the pre-show. We're not allowed to talk about the topic. So we're talking about drinks. A homebrewed, dry-hopped American IPA. Whoa. I'm not much of an alcohol drinker myself, so... Crank it back up. I cranked myself a bit too much there. No, I think it's okay right now. It's not at the usual level, so should be fine. I always enjoy the music. Right. So, did I charge this thing? We might need it. 40%. Okay. The thermal camera thingy. But it's at 40%. That should still last a few days, actually, with this thing. So, can I see myself on the thermal camera? There I am. It doesn't want to focus. Oh, there we go. How many degrees am I? There's a hot spot on my nose. Oh, I'm actually quite hot. Okay, never mind. Lidl has these Christmas tree lights that I previously couldn't control through Home Assistant as they were not open about the protocol. I think someone finally reversed engineered it. Nice. Hello from Ottawa, Canada. Thanks for posting and sharing your amazing products. I look forward to using your dig boards in my show car. I would love to pick your brain and have a discussion. Cool. Well, join the Discord. I'm on there daily and just like a lot of other smart people. So definitely join on the Discord. It's on the first page on Quinled.info. And yeah, let's discuss that. You look a little bit green today. That was the thermal camera, I think. So yesterday I spent the whole evening, or lots of my evening. I got a new box of Cat 5e, and I basically crimped it into all kinds of segments, so the box is now empty. I made 100 meter segment, and then I made, I think, two 50 meter segments, and then I made 4 25 meter segments, so we can use that during testing today. I don't know, Philip. I don't know, Johnny. I've been suspicious about that too. So, seems like about 50 people showed up, so that's good. What are we going to do today? Well, actually, we can talk about what I've already done, and then we'll talk about what we're going to build together today, because we're building another prototype. And after that, we're going to test it, and this is going to be an important test, because if this works, it's going to be very nice. So, first off, I guess I'll explain it to you with all the various parts. So first off, we have my mouse was empty, so I have to charge it. First, we have a dig quad, right? And this dig quad has 2 data connections going to a new board. And this new board is called a Quinled data diff. And that is part of the differential segment or differential lineup I'm trying to build. It's not fully hashed out yet, and we're still prototyping, but this is something I want to release in the future. But basically, this takes in 5 volt to, well, about 55 volts. Anywhere in between is fine. And then it takes in 4 data connections. And it transfers transforms those data connections into a RS485 signal over UTP or Ethernet or whatever untwisted pair wire. Or, no, not untwisted pair wire, unshielded twisted pair. And, well, that's basically all this board does. It transforms the LED signal into an RS485 signal, which we run over UTP cable with an RJ45 plug. Whoa, Medved enters the chat with small token of appreciation for the excellent advice and assistance received by yourself and your moderators on the Discord. Thank you very much there, Medved. That's very much appreciated. And glad to hear it worked out. Yes, this is exactly like Andy Igley already says, for long data lines. So basically, with the dig boards and their output tuning and things like that, we generally can reach 5 to 10 meters okay, unless you're in a very noisy environment. But sometimes you just want to go further than that. And with this solution, well, the last time we tested it, we had this board and this board. Hold on. So the last time we tested it, we had this sender board and this receiver board. And this is a one-channel sender and a one-channel receiver. Now, I'll probably be making those two, but in some situations you might want more than one data line. And that's what we're experimenting with today. So I've already updated these, but I haven't built them yet. I'll do that off stream. But these worked up to 250 meter that we were able to test before. But now we have a lot more cable. So I guess we're going to see. So what is the real-world application of such a board? Well, if you want to keep your controller in a central place and your power supply and things like that, but your LEDs are 20, 30 meters away, or you have to snake through a not easily accessible part of the house, or you need, I don't know, things like that, or you encounter interference on those longer data lines, you can transform, well, with this board, a single data signal to RJ45 in differential, and then bring it up to, let's say, 250 meters. But, you know, if it's only 30 meters, that's fine too. And then you have your data signal there, and you can have a power supply there, and then inject data and power into the LEDs while keeping your controller locally, basically. Why would you do that? You can integrate it on the dig quad. Well, yes and no. Anything you integrate will mean it's a feature that everyone gets. And a feature costs money. And if it's something not everyone uses, or at least let's say 75% of the users is going to use, that's money. All those users are going to be paying that they're not going to be using. So first off, we're going to make these external solutions. So you can buy, you know, a set of these two and then extend one data line. And later, like this Ethernet version, I'll probably make an AE Plus version where instead of an Ethernet hat, it has an RJ45 or a differential hat on there. And then you can use that. So you don't need an external board. You can plug in an ESP32 with a differential hat on top of it. But while prototyping, it's easier to build an external solution like so, and like this one we're building today, or we'll be building something in this lineup today. Yeah, and then it's an add-on for the people who need it instead of something mandatory that's on the board and everyone's paying for, basically, right? Yeah, and the receiver can't really be integrated because that's, you know, a whole different deal. Now, I've already built more. So this is a ecosystem in itself. This is a one-port, one-channel sender and a one-channel receiver. And this then also has a fuse and a capacitor on there, etc. So you hook up power locally to it, and you get your data signal from a dig quad that's 50 meters away or whatever, right? But we talked about that in the last live stream, and we showed that and we tested that. This time we have a sender 4, so this breaks out 4 channels. And the idea is that it's more of an ecosystem where you maybe have 3 or 4 spots that you want LED data, but you still want to have a central controller. But you can't run Ethernet there, although you're running RJ45 anyway. Or rather, a data signal like on a normal wire can't reach it, but you still want to use your central controller. And for that, we have developed some boards, and One of them is this guy, and I actually have two of them. Because I've already built this one this week. And this is a receiver 2. So, sorry, that's not correct. This is a midpoint 2. Because this guy sends out RJ45, and then it goes to the top port on this guy. And here it has 4 switches. Let me remove the second one there. It has 4 switches. The donation is blocking the view. Well, I guess it deserves it. Anyway, it has 4 switches, and you can break out 2 of the data paths or 2 of the data lines on this board. So over here you have data 1 and 2. And, well, you can select with the switches which one of the pairs, there's 4 pairs in an Ethernet cable or a UTP cable, you want to break out. So let's say we want to break out pair 1 and pair 3 locally on this board. We can then connect another UTP cable and go to a second board which it goes into, and there we can take out 1 or 2 channels again. And let's say we took out 1, we can then take another UTP cable out of this one and go to another one, and then break out our final channel. So because you have 4 channels, right? So that way, if you have a multi-point system, like, I don't know, you want to put them somewhere in your garden and you want to have 10-meter runs in between of them, something like that. Or there's loads of scenarios where people might want to do a roof line, and one is 15 meters away and then you need another one 10 meters away from that, or things like that. You can actually daisy chain these boards coming in and going out, and, well, you have 4 channels, and these are the midpoint receiver 2. And this one also integrates, well, a beefy input terminal. It can do about 20 amps. It has capacitors on board fusing, power distribution, things like that. What we're going to build today is the midpoint 1. And the midpoint 1 is basically the same as a midpoint 2, except you can only break out 1 channel, and it has a little bit less power distribution and things like that, right? Yeah, that's basically the idea. So it's basically trying to be, or I'm trying to make it a full solution for doing long data wires. So if you have really spread out stuff, or you want to do props in your yard or things like that, well, that's what these things would be for. Almost missed it. Philip is here. Nice. Sure, Danny, and even better. I guess I shouldn't mention that, but still, once the ESP32 with the top hat for the RS45 is here, if you don't want to run any local channels, you could actually just get just the ESP32 and then the differential midpoint and receiver boards, and you'd be done. You don't need the dig board at that point, because, well, if you look at the components of this board, it basically has the power in, the fusing, the capacitors, level shifters, etc., just like the dig quad has. Slightly smaller form factor and optimized, and yeah. Already a secret. What? What secret? I think you can put a female RJ45 connector with 1 data line. What? Journey started with 33 ohm resistors. Yeah, exactly, Timothy. All the brain, or, well, the ESP32 would be in your house, and then you just have a dumb receiver board outside of your house. Oh, differential ESP hat. Yeah. Well, as I mentioned, that is fully in the planning, and I'm also looking to do something in the Dig Octa lineup. But currently we're developing an external solution, and then once all that is hashed out, etc., it'll be hopefully relatively easy to basically put everything that's on here onto a hat that'll work on the ESP32. But this system is also, it has some nice features that are not immediately apparent. Because this will do 5 volt to 48 volt or 55 volt, while a DIG Quad or a DIG Uno or even a DIG Octa can only go up to 24 volt. And the receiver board, if you have the version that's fitted with these PTCs, is also rated up to 55 volts, where this only does up to 24. Now, there aren't really any addressable LED strip that do more than 24 volt, so it doesn't really matter at this point in time. But in the future, if somebody did make 48 volt LED strip and you wanted to run that, this guy couldn't do it on its own, but I'd still have options available to run them through these guys, right? Your add-on is obsolete thanks to your older solution, ESP32 plus LAN. Well, sure, but that's still different. Let's say you wanted to run LEDs above your ceiling, and the only place there is where you could put a power supply and a controller is in your ceiling. But that ceiling wouldn't be easily accessible. If you'd have your ESP32 there with a LAN connection, that would work fine. But now you're updating or rebooting it and it doesn't come up. It doesn't start anymore. Or you flash the firmware on there, that's not compatible. So it bricked. And you need a USB connection to revive it again. If you had one of these boards in your ceiling, that's fine. This thing doesn't have any firmware. It has auto reset fuses. It basically can't break like that. So then if you have your controller in a central location, but have a dumb board in the remote location on top of your ceiling, whatever, then it matters a lot less, because that basically can't break the same way a controller can, right? So I see some options or some things there. Well, Danny hits a point there. We're first developing this system, but if there is time tonight, and I should really get going with doing the actual stuff, we're going to do some tests if not PoE, but still power over an Ethernet cable is going to be viable for some solutions. And I have some plans with that. And if that works, it's going to be really nice. But it's not going to be official PoE, because that's just, I still don't see a use case for that. It's way too expensive. But we are going to look into that. So, yeah. Oh, PoE in, PD 3.0 out. Sure. If you can spend like 40 or 50 bucks just on components alone, you can do that. Or you buy like a 12 volt power supply for 10 bucks. I mean, I get those solutions, but hardware wise, they just don't make sense. You have to buy an expensive PoE switch. Then you have to buy the chips, etc. to do PoE. Then you have to make it power delivery compatible. Or you just buy a power supply that's like 1/5 of the cost, and you, yeah. I used opto isolators. Cool, yeah. A DIG fusion. What? What's a DIG fusion? No. That's okay, Andy. No, the analog breakout board is the dig to analog. I've been doing a lot of work on that too. It's basically finished. I need to hash out all the BOM and other files so we can get production started on that. But that's another thing. You can use that in conjunction with these boards if you wanted to. Anyway, it'll become clear later on in this live stream, because we'll be using the sender 4 to go out with a UTP cable into a midpoint receiver 1, and then looping it to another one, and then we'll throw some midpoint 2s in there, and we'll see how far we can stretch it. Maybe we can still go 250, 300 meters with all the boards in between. That would mean you just basically have very high flexibility in how you build your LED setup, no matter the distance, right? And then power things are something for another time. But maybe we'll do it as a secret at the end of the stream. But I need to get cracking on this, because otherwise we're going to run out of time. So let me get my mouse out of the way. Stupid cable. Because we're going to be live soldering again. It's always fun, isn't it? Yeah, they have that divide. Oh, look, there's a little spider. Well, I am in the garage. Spider's gone. Yeah, basically you have active PUE, that is the official PUE, and you have passive PUE, and that is someone put voltage or power on my UTP cable. No protection. Plug in whatever you want, it might blow up. Yeah. Okay, let's get our pieces out. No, with that one. This block is here. Block. So, I need to find the right boards. Oh, might have actually immediately found the right one. Yes, nice. And now I need to find the right stencil. Because I have a box here from PCBWay that came with 5 different PCBs and 5 different stencils. Let's see here. No. Oh, this could actually be it. Wow. Mostly my luck is that it's the last one. Do you guys have that too? That if you have like 5 options, you have to go through all 5 of them and it's always the last one? Let's see if this lines up. I think so. Yeah, we got the holes. Yeah, it's a relatively simple board. There's few SMD components on there and then a lot of through-hole stuff. So we're going to do both today. So let's get this jammed in there. Of course. Or you get like several options. Oh, what the? And you're like, it can't be that one. And you check all the other ones. Of course it's that one. Okay, let's yep. Oh right, I had to squeeze some stuff here, so let's see here. Nope. There. I need to hang over it because otherwise I can't see it myself. How's that? That looks pretty good, doesn't it? Yeah, let's stick that down. There. I guess I should zoom you guys in more. Something like that. Yeah, kind of like that. Yeah, James. In this case, I only see it as a one-channel system. So that's going to take up 1 pair. And then you'd still have 3 pairs left for power. And as I said, if we have enough time today, we'll jerry-rig that. And probably blow something up, but who knows. And if that works, once I've actually tested that, I will likely build some boards around that. But the problem with that type of solution has always been, if you send... So PUE works because you send 48 volt in, or 55, 57, whatever, but the end device always down converts, right? So a PUE device gets 48 volt in on its port, but it doesn't. It doesn't get 48 volts in on its port. You send 48 volts, and then 36, 42, 39, 24.6, whatever, something like that arrives there. But a PUE device, an active PUE device, will always have a buck converter on it to take in whatever voltage is coming in between 24 and 60, or 23 and between 32 and 60 volts, and then down convert that to whatever voltage it needs, right? Now do this for LEDs. Let's say we have 12 volt LEDs on the other side. If we send 12 volt, maybe only 10 volts arrives because of voltage drop, etc. That doesn't work. And that's, what a lot of people try to do, but you shouldn't do that. So I want to build a system where we send 55 volt in, and then on the receiver part, which I'll design, we down convert that to 5, 12, or 24 volt, whatever our LED strip needs, and then it can work. What? Yeah, I have gigabit PoE. I use gigabit PoE in my house for all my access points, etc. And you have 10 gigabit and 2.5 gigabit PoE. That's no problem. Johnny wants like a 10 watt laser on his fiber cable. Okay, let's get some paste on here. Don't need too much. That's good enough. Wouldn't that be funny if you have like a 10 watt laser on your fiber? You unplug it and suddenly it's like zoom, you start burning holes in your wall. No, Andy. Proper PoE is not negotiating voltage before sending it. It is always 48 to 57 volts, but it will negotiate before sending power. I think maybe that's what you meant, but yeah. So, let's try and spread this. Yeah, that worked. I think. Let's see. Now, I'm building 2 because I need to. Yeah, that looks good to me. Yeah, officially PoE on Ethernet is also isolated. That's correct. But the clue is that it's always converted on the other end. So the receiving end always converts the voltage down to whatever it received. And if you have a device that expects 12 volt and you send 12 volt in, that's going to be a problem. Okay, let's do that again. Oh, that's not great. There. Yeah, I'm building 2 because basically building 2 takes 1.25 the times of building 1. Yep, that looks good to me. Yeah, I really like these spreading tools. I should have linked them maybe in the description. I know I've linked them before, but it's basically basically they're a set you can buy on AliExpress. There's this spatula type thingy, but it's completely flat, so that's nice. And then there's this guy, but you can really, push down on it in a nice angle, and it doesn't flex or bow or anything like that, and it works really well. I can definitely recommend those. I don't have the link right now. This must be a recording. Yes, this is a recording. You got me. This is just a live narration over something I've done like 50 times to get it right the first time. And then I had to edit it, and, this is a perfect YouTube video. You can also almost get all of the paste back off of it again. So that's nice. Since I started using stencils and one of these little pots here with paste in it, I save so much paste. And it's so much neater. It's more expensive because of the stencils, but yeah. The AI voiceover, I'm not even really here. I just trained an AI for like 2 hours. Got a bunch of, NVIDIA cards and... Current limited negotiated PUE can power displays, laptop, etc., but only after checking for smoke. Yeah. Well, if the problem is with the current PUE standard, so AF and AT, 15 watts and 30 watts, or 20.5 and 25 watt effectively, it's not really useful for LEDs. We did tests with that. I have a whole article about that. We did a full live stream, how much you can actually use from that. But the max you can use for LEDs is with 5 volt and about 4 amps continuous. And then it's done. Then it's just not going to give you more power. And I find that lacking, because you still have to buy an expensive PUE switch, and you only get 20 watts per port out of it. I mean, just buy a power supply. It costs like 1/5. So what I'm thinking of is doing it differently with custom hardware that costs a lot less, and also integrates the sending of the LED data. And I know there's going to be a lot of comparisons with PUE, and I get that because it's power over an Ethernet cable, but it's a different way of doing it, and I think it's the better way. But we'll see. I don't know. I haven't built it yet. I haven't tested it yet. So I always have to put the stencil back where it came from for myself, because otherwise I'll instantly lose it, and then I want to build another board, and I spend 5 hours looking for the right stencil, and it's never to be found. There. Okay, let's get the magic onderzetter. Oh, there. The nicely scorched. Do we want this nicely scorched side or this one? I think we go for the absolutely scorched one. Call it PUE. Power of Ethernet, but different. Yeah, I don't know. We need to think of a good name for that. How do I want to build? I think I want to build this way. Not sure yet. Okay, now we need an IBOM file. Let's find that. Receiver 1 midpoint. Okay, good. Let's put this in dark. I'll show you in a minute, don't worry. Let's get this back over here. And I think if we enable this guy, there. Ho, ho, ho. It is amazing. It's a little bit in the chat, but what are we going to do? We only have so much space. Okay, I'm trying to make sure you can read the components. I think you can now. So, as I said, we'll be building 2 at the same time. What? Oh, you mean the stencils. Yeah, the DIY Dig Quad and Dig Uno, I especially built with 0805 as the smallest component, and those are easily done by hands. I also made sure that all the pads are hand solder pads, so those are wider and further spaced out, etc. So those are easily done by hand. But like these are 0402 components and not hand solder pads, etc. And you'll have a hard time trying to, hand solder those kind of components. Let's see here. We need a pair of tweezers. And let's clean it using my proprietary cork cleaning method. by just sticking it in my cork a few times, and then you get perfect non-sticky tips every time. It's amazing. USB-C is the new PoE, ain't that right? Let's see here. We need some 0402 capacitors. Let's start with this one. And I need more cable. Yeah, that should work. Or is it over here? I think that box might be over here. No. Yes. Good. Let's start with this guy. 10 UF, 10 volts. Okay. That should be somewhere in the back. 10 UF, 10 volt, 0402. The secret is out. What secret? All these secrets the whole time. Well, for you guys it wasn't a secret anymore. For Philip and CJ and Andy. But still. My image isn't rotated the same way. That's very confusing. Let's, there. Otherwise I'm gonna get lost. Okay, I got it. Wow, that's a big 0402 there. Huh? I'll try and zoom it in a little bit more. We'll take a look at it under the microscope later. Oh, yeah, there we go. Oh, okay, that's better. A 1 FPS rotate there, right? It was very smooth, manually operated. Okay, let's click on this. Placed, and I want to see the first pin. Oh, yeah, okay. So, these are done. Beam. Okay, 1 UF. Okay, let's put this one back. 1 UF. Okay. 10 volts. Okay. I did wonder when Cisco released a WLAN AP with multiple PoE to aggregate power and uplink data over long distances. Yeah, you can do that. Where does this one go? Over here. Okay, done. Okay, we need some 0.1. How many volts? 10 volts. Okay. And one stronger out. What? That's interesting. Oh, we only need one of those. Okay. Yeah, these boards are more through-hole components than surface mount. But, you know. Yeah, the new pick-and-place machine from Quindor. Turns out it's Quindor himself. Okay. Resistors, okay. Do I maybe have that one here? No. No. Okay, we need a 1206 100 volt. Oh, yeah. I'm getting really tired of this mouse being plugged in. I'm gonna unplug it. Hope it lasts. There. 100 volt, 2.2. Do the dip switches have to go through mounting pins? No, those aren't actually dip switches per se. They're, yeah, I guess normal SMD switches. Already done with this guy. Okay. Now, these are big. Where did we go? Come on, mouse, you can do it. There. There we go. I'm going to skip this one and we're going to go to 0402 resistors. Oh, wait. That's a capacitor. How is this sorted? Why is this here? Strange. Strange. All the other capacitors. Or resistors. Okay. Okay, we need the other box back. 0402. Well, since these are prototypes, they haven't been bomb optimized yet. Where is that back? Is it over here? Oh, right. No, it's not. Okay, I'm gonna try and put this guy here. No, I'm not. Okay, I'm gonna use this. I thought I had a better 50 volt 100 NF, but I don't. I'll need to check that. I'm confused where it is. Okay, that's fine. Goes over here. There we go. And now we get to the resistors. Whoever said resistance is futile, I know who said, but they were wrong. We very much need resistance. Otherwise, all these boards aren't going to work. Okay, some 33R resistors. I thought about putting resistor switchers on these boards too, but that would kind of impact the form factor a lot. So currently they're using 33R resistors. Which should work well in most cases. Let's see, these are over here, I know that. Well, it was the board, and they say resistance is futile. But funnily enough, they're electronic beings, or bioelectronics, and electronics needs a lot of resistors or resistance to work. Resistors are futile. We should make an edit. Let's see, we need 3 5.1K, okay. Andy says, I like that mounting hole placement completely over the silk screen. Do you use custom DRC rules to make KiCad scream less? You know, KiCad often wants to burn and die when I'm working with it. It's like, what are you doing? You can't do that. Stop doing that. So, and then you just, you know, hit ignore like 50 times, and then it's like, okay, everything's fine, no problem. I see no problems here. What are you talking about? Let's see here. Oh, there's two 5.1s there. Okay. Funnily enough, sometimes then PCBWay comes in and he's like, and they're like, hey, did you know your silk screen is getting clipped like really badly? And I'm like, yeah, no worry about it. Just make it. Just you know, send it. And they do. Right. Let's do the LED, because that's also in that spot. Sorry, Johnny, I still don't have any 0402 pink LEDs. So they're going to be orange. Now, these are always bugger, because they're a very tiny component that is directional. So let me get my magnifier. And I actually need to use the small magnification piece here, because the dot is on this side over here. Oh, you can't see that. Over this side over here is the dot. So I need to find... Okay, and I need to turn it around, damn it. Of course, it never wants to let go. There. Okay. And for this one, the same thing. Also the wrong way around. Okay, we'll do some end adjustments under the microscope before we reflow it. Okay, we need some diodes. Where's the box of diodes? No, don't need this box anymore. Whoa. There's no box of diodes here. That's because it's in my closet, cupboard. What would be the correct term for that in English? In my closet or cupboard, or does it depend if you're British or American? Oh wait, those are over here. Yes. Okay, never mind. Oh, is it turned upside down? Let me check. It is. There we go. Are you happy now? Shelves. Yeah, that's true. They are shelves. That's right. Okay. There. Let's put on a level shifter, and then I think it switches and the RS485 chip. Oh, and an LDO. Oh, no. Oh. 1 moment. Okay. We need 2 of these. Oh wait, that's the wrong one. Oh, damn it. Okay. Wardrobe is UK version of closet, I think. Probably right. I got the 4-channel version, not the 1-channel one. Put it back in the baggie for later use. Yeah, I need these. No, these are also wrong. Jesus, what am I doing? Yes. The sound now is quite nice, so I think only minor tweaker should do it to be perfect. Okay. 1 moment, please. I always wrestle with these plastic tapes. I really like the paper ones a lot more. Pants or trousers? I don't think I've ever worn a trouser in my life. I wear a lot of pants though, so. Okay. Now these should go on pretty easily because they're directional. Something like that. Okay. Then we need some differential chips. Yako, that is absolutely fully correct. Oh, Johnny's gonna leave. No. What are we gonna do without you, Johnny? What is this? Why are you abandoning us? Okay, like that. I need to check some components real quick. Yeah, we'll check it in under a microscope in a minute. What are we going to do without Johnny? Easy. Orange LEDs, not pink. Okay, yeah, we need this guy. think last time I cut off a lot of the component tapes, and I have to reopen them. 1, 2, let's go. Okay. We're getting there, we're getting there. Seems likely. Just label the passive PoE cable to avoid smoke. Yes, yes, that's going to be the biggest downside of this, of using a type of cable that is, I guess, officially for something else. If you plug it into something that isn't designed for it, and there's 55 volt on there, that will most likely kill it. Okay, we need the PTC, and then I think we need the switches, and then we're there. Look at that, a box with PTCs. What footprint is this? Oh no, we don't need that PTC. There's no PTC on here? Right, because it's behind the fuse. Need to think about that if I want to keep it like that. Where's my notes? Let me make a note real quick to evaluate something. Okay. Oh, I guess you could see my notes there. That's not good. Right. So we don't need a PTC. That's a through-hole part. Okay, where's my switches? Don't need mounting holes there. Switches, okay. PCB switches. Ah, right, yeah. The reason these cap footprints have 2 holes is because when I'm prototyping, I'm not yet sure which exact capacitor I want to use, and I often build multiple prototypes and then test different types to see how the system responds, and etc, etc. So that's why I use this footprint, because then I can, you know, experiment with a wider range of capacitors fairly easily. So these are dual pole switches. So once you flip the switch, it actually changes 2 lines instead of 1. And we're using a lot of them, but that's also the reason I don't use dip switches on this one, because then you'd have to flip multiple dip switches to change a single thing. And, well, I feel that becomes confusing quickly, right? So that's why I use a different type of switch, which switches 2 lines at the same time. Okay, let's tick that one off. And let's see here. This is a through-hole part. This is a through-hole part. This is a through-hole, through-hole, through-hole. And this is a through-hole. Good! Then we get to the camera inspection part, or the microscope inspection part. Whoa, 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 whoa. Let's turn that on. Wow. So this is a midpoint receiver, and it's meant to break out one of the channels and then transform it back into LED data, and then you can feed an LED strip with it. So let's see here. Let's zoom out a bit. No, that's in. Let's start at the top. Okay, let's zoom in a little bit. So these aren't perfectly centered, but they should auto align fairly okay. They're a bit heavy, so they don't always perfectly. So let me give them small nudges. There. That's okay. That's okay. Now let's take a look over here. RS485 chip. That will auto align, but let's nudge it slightly. Oh. There. These are fine. This will do fine. This one's kind of like, you know, how are you doing? Well, let's say that's improved, but now I knocked this one. Okay, that one's fine. This one needs a little nudge. That should be fine. That's okay. And then there's some stuff down here. Now I knew these level shifters were a bit wonky. There. Oh, where am I? There, those should be fine. That's fine. That will fix itself. That's fine. And that's it on board 1. So let's go to the second board. Okay. 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 Those are good. That's fine. Yep. Better? A little bit more. Okay. Okay. Sure. Oh, wait. Okay. Yes. Yeah, you can actually, you can zoom in a little bit more even. Oh, I'll move the camera. And you can actually see the individual solder balls. And I still need to make a video about this microscope. But it's really nice because it has a variable zoom lens on there. But you don't really have to adjust focus, sometimes a little bit. But you can basically focus in like this. But you can, by turning a knob, focus out like so. So you can get a pretty good overview. And then you're like, oh, wait, these 0402 here, how are those doing? And then you can get in really close and adjust them exactly without having to mess with the height of the microscope and things like that. So yeah. Okay, let's put this to the side because it's hot plate time. Hot plate time. Do 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 do. I don't know if that's an actually song. Yeah, if you want to get the brightest right now, I'd get that 24-volt addressable neon cop strip. Those are really, really bright. And a good second one is that WS2811 bright that Andy's talking about. Cooking with Quindor, yes. Okay, let me turn this one off. And I need to get this one in the middle-ish. Get some boards on there. Let me turn the power on. So this is still our live stream custom blowing out the power 5 times hot plate. But it's still working well. Is that the most zoom we'll get? That is the most zoom we'll get. Yeah, if you want the brightest, I'd rate that 24-volt addressable neon one as the absolute brightest, and a good second to that is the WS2811 bright, for sure. Does this hurt the board? I don't think it has feelings, but I don't think so. No, there's actually no lead, because this is leadless paste. It is 138C paste, so it's very low temperature paste, but there's no lead in there. We are going to solder with leaded solder wire, though. Oh, you got the 2811 bright right now, but not lighting the background as much as I would like. Oh, wow. Okay. So, Tom, especially in this case, we're using 138C solder paste, so Celsius. Which is a fairly low temperature, and my hot plate, it's currently at 83 degrees, is going to 155, and that's basically a temperature that's still pretty low for the components, because normal paste you solder at like 300 degrees or something like that, and then you need to take into account that they don't stay that warm for too long. But with the low temperature paste, it's much less of a problem, so that's what I use for prototyping. Because then I can easily still change components and, work on it while it's warm. But production boards are all, with high temperature paste, etc. Well, take a look at the video I have about that. If you look in the Intermit.Tech YouTube channel and then search for addressable neon or something like that, you should be able to find it. Oh, we have smoke. We have smoke. Smoke is confirmed. Okay, it should start. Yeah, you can already see it turning into solder instead of paste. So let's let it bake for a little bit, and then I'm going to do a small inspection with the magnifying glasses, and then we'll check it. Wrong kind of smoke. This is the good smoke. So I'm going to check it real quick, see if there's any obvious issues. There's not that many components on this board, so. Let me nudge some components real quick. Oh, that's a bit too much nudge. That all looks good. Yeah, looks good to me. Do you see any kind of issues? I see all kind of wobbling from the heat on the camera. The okay kind of smoke, not the magic smoke. True, true. So let me get the boards off. And then wait just a second or so for it to cool down a little bit. And then we'll get the microscope out again. Okay, let's turn on the microscope view. And hot, 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 hot. Let's get a board under there. Now, I put it on the metal directly so it cools quicker. But then I do have to refocus it. There. So let's check the joints. It's a little bit more. There. Now, those look perfect. Perfect. Good. Good. That looks fine. There's a little bit of corkboard here. There. That's fine. That's good. That looks fine. Could have pressed this one down more, but that should still be fine. And that's already it. That's already all the SMD components on here. So let's check this one. That's okay. That's good. 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 Sure. This pad's a bit anemic. Could have used a bit more paste, but should still be fine. Same one over here. Yeah, that'll work. Wow, I actually burnt my finger. Okay, good. We can remove the microscope again. Oh. I believe the link for the microscope is still in the video description. It's really nice. If you're doing this kind of stuff and you need a good microscope, that one I can recommend. Okay, now it's through a hole time, right? So let's get a big capacitor. I think I need to go here. I still need to order the actual capacitors I want to use on this guy. But for right now, we're using 80 volts, 180 UF. That's fine. So I'm going to insert all the components. Am I doing this right? I'm not doing this right, am I? Not paying attention there. There. Need to get the plus and minus right. I'm going to insert all of the components and check if the spacing and everything works, because this is the first time I'm building this board. I have no clue, right? Let me put this guy back. Okay. We need a 2, a 3, and 2 2s. A 2 and 2 2s. A 2 and 2 2s. Actually, I believe the 12 volt of the neon strip is slightly less output than the 24 volt. That 24 volt is insanely bright. It's amazing. So let's put those in. There. Oh, and we need to make the I like this so much. So you can take these two screw terminals. I can't really show you that well. And then you can just hook them together like so. And now you have a 4. Okay, so that's screw terminals done. And we need a fuse or a fuse socket or a fuse or a PTC fuse. And I think in this case we're going to use a PTC fuse. And then we need the two RJ45 sockets. So let's do the RJ45s. Oh no, I barricaded my own stuff. So I intend to use some yellow sockets for this to try and indicate like, hey, this is not Ethernet. Don't put it in your switch. Okay. And let's get some PTCs, because then we don't have to bother with a fuse. Let me check where I have those. There. Whoa. Okay. So let's get some 60 volt 5 amps. And we'll start with 5 amps for each one. Yeah, Dig2Go actually has multiple PTCs because the onboard electronics and the LED current, I guess you could say, are fused independently. Okay, so these are a just fit. So I actually have to tilt it in there and then push it, and it kind of locks in place. That's pretty nice. It's a custom footprint, but it worked out pretty good. Snap. I like snaps. And with that, I think all components are on there. So these we need to solder. These. This is actually slightly a clearance issue, I'm just discovering now. It'll just fit, but barely. Alright, so this is actually touching. That's not great. But, okay. It'll work for now. Ooh. Okay. Doesn't want to go in. There. Rhythm is our dancer. I like snap too. Nice. There we go. And that's how it will look. But we of course need to solder it first. Now I'm going to remove the PTC. And most of the other stuff is actually pretty much the same height. So let's see if we can flip it around like that. Nope. Nope. Oh no. Okay. I need to do the capacitor later. That's fine. There. Okay. Let me get my fume sucker. Oh no, it's already on. Okay. Hold on just a second. Okay, and let's get my soldering iron out. Why are you making noise, phone? You shouldn't make noise. Hey there, Christian. Of course, there's all kinds of crap on top of the wire from the soldering iron. I always hate that. There's so much crap on my desk. There. It's mostly free. I'll take it. Right. Yep, should be sharp. We're using the big tip for the initial stuff. Oh wait, do we have to turn it on? Haha. Okay, I always tack on one, and then I check if everything is aligned correctly. It's not really, because, well, we need to push this one in more. Like so. Always amazes me how much the board can actually heat up while doing that. Yep, okay. Those are no good. This one's still lifted off a little bit. There, those are now perfectly aligned with the edge of the board. So now we can solder all of them. We need a bit more room. These are actually 4-layer boards, so you need to have a good soldering iron to get the heat in there quick enough. This is actually some different leaded solder. I don't think this is one for professionals. No, this is one I got from AliExpress, and I like it a lot, so I actually ordered a new spool of 500 grams. More flux? No, these are perfectly soldered. What are you talking about? Look at that. Look at that. That's great. I don't need more flux. Okay, I'm actually changing my mind. I'm going to put a PTC in one, and then I'm going to put a fuse socket in the other one, just to make sure it actually fits. So this one gets a PTC. Oh no, I need to do the cap first. So the capacitor is slightly higher than the terminals, it turns out. Okay. Lewis amounts of flux. Well, when you're reworking something, yes, but when you're soldering something, it shouldn't really be needed. There. Now let's make sure that's on straight. It is. Okay, there we go. It's nicely tacked in there. And I do like to fill both pads. You know, can't hurt. So let's put a PTC in here. There. And let's check the alignment, but the alignment's pretty good. That's fine. Okay. I'll look up the link in a minute there, Tom. Where did this subble not Ethernet go? It's right there. Hold on. Well, here it's gone. Not Ethernet RS485, but it's still over here. And this is the inside, and this is the outside. But that's also on the back, so in and out. Clearly labeled. Okay, PTC is done, so now we just need to do the Ethernet sockets, but I need a different tip for that, so I'm going to change to the other board and do that first. Aesthetically displeasing. Sure. But when you want a 60 volt fuse, you know. Okay, let's get the second one done. Why can't they stand straight? What do you mean? So this will need some fixing. Come on. There. There. Okay. They're also good for playing ping pong. Okay. So, capacitor. Ah, right. Well, they are actually designed to be on an angle. If you look at the PTC on the bottom side here, you see that they're not fully aligned straight. So on my footprint is straight, as you can see here. So my footprint is straight, and that's why it's at an angle. So I can show you better when I have the legs snipped off. But as you can see here, I have it straight on the board, but then it is in sideways. Now you can actually just twist it, because they're very manipulable, malleable. I don't know. But yeah, they are designed to be like that. What are we building? Well, this is a midpoint 1 receiver, which is hopefully going to be part of a new differential signaling system I'm building. Okay, let's check it. Multi-use, yeah. There. Yeah, I need to see. Maybe I can change the design where we can lie it flat, but then you can't really reach the switches anymore, so I need to think about that. Right, we're not going to put a P2C on this one. Because I want to see if a fuse holder fits. In theory it should. Oh, right. I do need to solder the other legs, of course, here, but let's put the fuse holder in and see if we can make... Oh, look at that. That is a snug fit. But it's in there. It doesn't obscure the text labels. Wow, okay. Can I solder that without it falling out? Let's hope so. Let's try it. Okay, let's see if it's in straight. Yep, that's in there snug. And especially because there's a component right there too. So, I mean, it really fits in perfectly. It's like almost touching the fuse, or the capacitor. Wow, okay. Okay, let's solder the rest of the legs. This light comes on and off sometimes. It's annoying. Okay, let's give this a little tack. But okay, that looks good. Nice little mountains. Look at that. No extra flux needed. Now for these, I might need some extra flux, but we'll see that in a second. Let me get my snips. And we'll also have to snip the PTC legs. There. Nicely snipped. Okay. Right. So now we just have to do the Ethernet sockets, or the RJ45 sockets, or whatever you want to call them. It's going to be annoying because we already soldered this high piece here. On this one it's easier. Now I'm going to change my tip to a finer tip because... Jesus. What the... Get out. Okay. Okay. I guess we'll do this one first. Oh, there we go. Like that. So this tip is a lot finer. And I'm using the Ixum T3A soldering station. I like it a lot. Works really great. There, those all look good. No, don't put solder there. Okay. There's a little bit too much solder on this right pin here. Let's see if we can swipe it off. That's going to be tough with this this tip here. Yeah, I can't get it off with this tip, but let me get my other tip again. The Ixum T3A. If you search for T3A on AliExpress, you'll likely find it. There. A little bit more. There. Now it's perfect. Good. Those all look fine to me. Yeah. Next. I have to switch the tip again. Okay. There we go. That again looks fine to me. Yep. Cool. That means I think we're done. I'm going to flip all the switches to the down position. just to be sure. There. And let's clean up a little bit. Let's act like we're never gonna rework anything, because it's gonna work perfectly the first time. So we're gonna clean everything up, and then we're going to test it. That's always the best plan, isn't it? Remove all the tools, then test it, then find out, of course, you made a mistake, and then have to get all the tools again. Let me get you a link for that solder, because I really do like it. I mean, I actually went back, looked it up, and ordered a 500 gram roll, because I liked it so much. Oh, the original page where I bought it is gone. Okay, well, the 500 meter one, a 500 gram one is here. So I got the 0.6 millimeter, I think. Let me check. Yes. The 0.6 millimeter one, millimeter version of this solder wire. And this is a 500 gram spool. That might be a bit much. But they should also have a 100 gram spool. Let me try and find it. Yes. This is the 100 gram version. Might be better to start off with, because depends on how often you use solder. 100 gram is already, you know, a good amount. I'm still running through the 100 gram roll, but I liked it so much that I was like, okay, I need to get more of this in stock. And what else did we say? Oh, the soldering station, T3A. Hold on just a second. So I have the T3A, T3A in T245 version. And there's actually one where you get the stand, and I do have that optional, more expensive stand. So I have this stand here. Won't focus, won't it? Well, okay. So I have the more expensive stand, and the nice thing you can do with that, I guess I'll show you over here, is you can put your iron like so, and then hook the tip. Oh, I can't really do it if not. Okay. Hook the tip, and I hold it down, and you can basically remove the tip like that. Let me get the other one. And then you can just take this tip, put it in the middle, push it in, and it immediately works. So, right? So now the big tip is on there. You remove it like so. You put this one in a little bit. You push it in, and it immediately works and heats, and it's done. And the iron recognizes a different tip, etc. So that really works nicely. Yeah, most of it is all on there. I think I still need to add the solder wire, or I recently did. I don't remember. Just the tip. That's right there, Felix. Okay, we have 2 finished boards. I flipped all the thingies down. This one has a 5 amp PTC. So for the other one, let's get a 5 amp fuse. there. So yeah. So this is kind of how they look. Did I snip everything here? Yes. Okay. So RS-485 in and out. And let's test that. I'm going to take a little break first. Let's get this board out of the way. All right. Big dig energy, boy. Okay. Whew. Oh, what fan was I using? Let me check, because this is one I actually got as a present. But it works. It works decently well. It's a Aten, easily safe. But I don't know which. Oh, it's an Aten ST. There, Aten ST 1016. Can we find that on AliExpress? ST 1016. Yeah, we can. Can I link that? I can. Nice. So this is just a fan, but it does have an integrated carbon filter and a little light up here. Now, don't expect too much from that light, but the carbon filter does seem to be doing its job. Hey, Churdo! Okay, relax a little bit and then we're testing. How many people are here? Am I going to drive them away by relaxing? 80 people are here. Very nice. Thanks for joining, guys. So it's 11 o'clock now, and we've been streaming for 2 hours already. Damn. Okay. We might not have time for the Bodge project. That sucks. We'll see. We'll see. All right. Only 40... Oh, I see 43 likes. It's okay. If you don't like it, but you still want to stick around, that's okay. It's okay. It's you know, it's a safe space here. You don't have to like. We have time. Yeah, I don't know how long my energy is going to last, but we'll see. We'll see. Did I miss some smoke? Yes, we had lots of smoke. We had, well, not the most smoke, but it was flux smoke though. So I've heard this evening that doesn't count. So, but we still haven't turned on whatever we built, so there's still a chance. Besides, you can already see like here on the side of the picture. Oh my god. Okay. Why? Stop it. We've got this here. This is 100 meters of Cat5e UTP cable, which I crimped yesterday. And then I have 2 pieces of 50, and then I have 4 pieces of 25. And we also still have that 150 meter piece in the box. Oh, this is another, oh my god. This is another 100 meter piece. So we've got lots of options to see how far it'll go. Oh my god. Okay. There. Safe space, huh? Only hazards like leaded solder, electrocution, magic smoke. Yeah. It's Cat5e. Yeah. Solid. Cat5e solid, but still, it's Cat5e. And oh, the big one. So this is for a future test where we're going to try and run power over it. This is 100 meter of Cat5e 24 gauge. Okay. And this, oh man, is really heavy. This is 100 meter of Cat6 23 gauge. So it's 1 gauge thicker. And you can actually really easily see that if I put it under here. Well, if you compare that cable, this is the 24 gauge and this is the 23 gauge. Now this mantle seems to be oh no, wait, this has a spacer in between, so that's also why it's bigger. But yeah, I had a really hard time getting these connectors on. I actually had someone help me, and she actually did a great job because I couldn't get it done. And she was like, oh, let me do it. And then it worked fine. When will we have some news on the Quinpower battery? So the Quinled project is currently slightly on hold. I'll be on a little vacation next week. And after that vacation, I want to pick up a lot of stuff again. Because I also need some construction folk. And it was bouwvak here in the Netherlands. So I couldn't get any. So once that is all done and said, so in a few weeks I'll pick that up again and we'll try and get that finished. So, yeah. Okay. This one is so heavy. It's... Okay. News on the Ultimate Disk project. No news. Iman, okay. Yeah, that could be an interesting project, but then you mean just on a disk or in an enclosure, or what testing scenario would that be? Because that would vary a lot, I think. And most power supplies have usage examples. For instance, the officially the UHP series of Meanwell, the passively cooled high tier series or high quality series, they officially need to be screwed down on a metal plate for heat dissipation, while the LRS series, which has a fan, has much less of a requirement like that. So you'll mostly see differences in there, and if both are installed correctly, they'll both function fine. But yeah, the UHP series needs some additional passive cooling material on which it gets mounted onto to actually get its stated values. Why do you need construction workers? DIY. I know, but I want to make some alterations in my electrical box and connection and things like that, and I'd rather have a professional do that. Right. So, I guess we need to test these little guys. They're pretty tiny. They're not big. One of the screw terminals is still on, slightly crooked. That's okay. Okay, so let's get my little testing setup here, and let's test basic functionality first. And basic functionality would be getting the mouse out of the way. There. What do we have here is we have a DIG quad with Ethernet. Doesn't really matter. It provides 2 data channel currently. That also doesn't really matter. Actually, it does. We want to change that slightly. We want to make it a 4-channel board real quick. Let me get some wire for that. Do I have some wire? I have some random wire here. That should work. Oh, it doesn't have ferrules. Oh no. This one has ferrules on one side. That already makes it easier. Don't I have more of that? Oh no, I don't have this here. Okay, I'll put ferrules on it. Hire Philip. He does it for free. Rewired my entire panel 3 times now for 4 months. In 4 months. Cool. Okay, let me put some ferrules on this. It's smoking time. No need to termination. What do you mean? I'm confused what you're asking. So, okay, let me edit these slightly. They're a bit too long. Aw, Philip, you have to go. Lots of work in the morning. Aw, too bad. Last steps before the concrete arrives. What? What's going on? we'll see. We'll see. Hopefully, I guess hopefully it does or doesn't blow. I don't know. Okay. So let's add some more over here. There. I get that, Philip. It's okay. It's cool you came hang around for as long as you could. So we basically just have a bunch of random data connections to the board here. And we also have a output of a positive and a negative, and that all goes to here. Now this board will take in 5 volt to 24 volt, so it doesn't really matter what we feed this board. We're currently going to feed it, I don't know. Well, it's currently hooked up to my bench power supply. That's fine, I guess. Let me see how we're gonna do this, because we need power for these two, and then we need to connect some LED strips. And I already have these boards, the midpoint 2 that are already pre-built, connected to 24 volt. So I'd rather leave those connected. Okay. Don't. So let's leave those connected like that. And then let's connect these to the 5 volt supply. I don't have enough sockets for that. Oh, I can turn the microscope off. Okay. One moment, please. Need to think. How is that still on? Oh, it's not. Okay. I need to see if I can put this wire in there. More extension cords, yeah. It's just not long enough. I need my multimeter. Well, that sucks. What's in there? No, it's probably something I need. Can't pull it out, can I? I'm gonna try and pull a plug out. And I don't know what will happen. Let's see. Let's try to pull this one out. Is my top cam still here? Yes. Because there's one extra camera plug there. And I don't need that right now. So it's always good unplugging random stuff during a live stream. That's the best way to do it. So this needs to go away. And I think I can plug this in, because that's the 24 volt version. Yes. Okay, so now these boards are powered. We're not going to use these right now, but we'll use them later. But that should mean that this is the 5 volt version. We'll need that in a minute. Can't you use some Wagos and just, you know, bench Wago it all up? Maybe I can use Wagos, that's true. But we'll, not for now, not right now. Okay, and I kind of want this plug. Let's take one of the boards. Now I need to remember which way around it was. I believe like that. Problem is, half of the screws are Phillips head and half of the screws are flat head. And I don't really like the flat head, but that's the prototype screw terminals I have. So yeah, so VCC fused, data out and ground. That looks correct. And we need some input wires, but this is a special version of the board because this is prepared to have a buck converter at the end if you want to. So we have the main input terminals here, but then you need to have a buck converter on there. We're not going to do that right now. So we're going to put our inputs on here. So this is either the, yeah, I think I put it on there, but it's really small. This is the VCC D out, okay, or main in. I need to work on the silk screen. That's okay. Okay, right. So we got some 5 volt cable for there to go in here. Let me check for some cable. Might actually fit. Yes, it does. Nice. So I got a random cable from the drawer and some LED strip. Let me. There. Okay, let's randomly wire up this power supply. I know you can't see the power supply, but it's a UHP 500 that is just slightly off screen on my desk. It's a bit long for pushing 5 volts to it, but we don't really care about that right now. So these receiving boards are also 5 volt to 48 volt compatible, or 55. As I said, these are the main input terminals, but this is designed to work with a buck converter if you want to. If you're not going to do that, we're going to use the auxiliary input terminals. And that's just these over here. And in the end, some diagrams will have to make that clear, but yeah. Okay, so that basically wires up the main power. Now it's safety glasses time. Because I'm now going to turn something on. Oh, there we go. Which I haven't turned on yet. Let's not connect the LED strip. Let's plug it in and see what happens. Ah, we get a light. That's good. Nothing is exploding. Oh, it's kind of boring again, isn't it? So let's connect an LED strip. Other way around. Oh, did I put the wrong... Wait. Something is smelling. Am I smelling something? No, not really. There's a cat here saying hello. Hello, cat. You meow. Yeah? Can you hear the cat? I think I put the wrong side plug on here. Damn it. Show cat. No, how? I don't know. No, I can't move the cameras. So this is the wrong side. Nope, still the wrong side. Damn it. This is the right side. Pick it up! This one doesn't like getting picked up. Could you hear him? This is a very vocal cat. He vocals a lot. Worst team ever. Oh no, I'm not even paying attention. You guys aren't either. I'm screwing in the data wire in the ground terminal. What are you doing? Wait, is this in there? Yeah, it is. But wow, that's flimsy. Okay. Yeah, yes, heard it. Nice. So why is this so flimsy? Hold on. Ah, because it's broken. Okay, that's fine. Well, we're getting ready to get to test one of them now. So, okay, let's hook up the LED strip. And in theory, nothing will happen. And I'll explain in a minute. So let's put it on there, I don't know, like so, right? Okay. Let's plug in the power again. Yeah, okay. Nothing happens. That's actually good. Let's turn this one on also. That's set to 12 volts and 0.5 amps. That's fine. Okay, now the sender board is also on. Now I'm going to open WLED. Okay, and I need to change the configuration real quick, because we need to add the extra channels. We're just going to add some channels with 100 LEDs. I don't remember my own GPIO number. I believe it's 4. Dig quad, pinout guide, yes. Okay, save, and let's make it do some color looping there. So of course nothing is yet happening because we're missing our UTP cable from there to here. So let's get a bunch of 25 meters, right? So this isn't super long, but it's not short either. And let's plug it in here. Okay. And now let's plug it in here. Now, again, in theory, nothing will still happen. Nothing happened. Why is that? Well, that's because we haven't flipped the switch yet. Because this board, although it can only extract one LED output, I guess I can lose the glasses now. Currently, it's not taking in any of the 4 pairs. So, in theory, I can flip this switch, and it works. And I can flip it off again, then the strip stalls, but I can flip another one, because we're sending 4 channels, and we're extracting one of the 4 channels. And, okay, let's turn that off. Let's turn this one on. Yeah, that all works. And let's turn that one off, and let's turn this one on. Excellent. So at the position of this board currently, where we can receive all 4 channels, which can do something individual, of course, and we can decide which channel we're going to extract. And all the other channels that you're not extracting on this board, which is max 1, and we have the midpoint 2 for 2 channels, and power distribution and fusing, go out of this port again. So let's hook that up. Right, so we need to hook up another board further down the line. What if you switch all? Well, I can show you. Then this happens. It doesn't understand. Now it's getting 2 LED signals. It's like, what? I don't know. So yeah, that doesn't work. If you use all of them, okay, I don't know. Let's use all of them. There. This is all of them. It's just spazzing out completely because it doesn't understand what's going on. Because it's getting 4 LED signals. But if I turn 3 of them off and 1 on, it's fine. Built-in flicker mode. So that works. That's good. We just built this and it works. And this is like, well, it's not a huge amount, but it's 25 meters, and a normal LED signal already has lots of trouble making it 25 meters, right? So, good. Working perfectly. So now, I need to get another wire and another thingy-bob. Let's steal it from this one. And one of the things I want to test today is how far it'll go. Because the idea is that you can have 4 chained boards, and each of them extracting only a single channel. So let's you know, make this board 2. Hey, Tech Turtle's here. You were positive it'll reach Canada without issue. Nice. Yes, this is 100 LEDs lit up. Or rather, we can check. I believe I have 100 LEDs configured on each port. Yes, 100, 100, 100, 100. Yeah. We're playing with some custom designed differential boards there at Tech Turtle. And this is now currently running through 25 meters, and we can select one of 4 channels. And we're going to add another 25 meters. And but I need a power cable for that. Hold on. No, that's too long. I might be able to get this into the terminals. I don't know. Yes, that's correct, Andy. The signal's fully stripped off of the forwarding cable. So those connections are basically left unconnected on the forwarding cable. Wow, I can't get these out. Oh, there we go. That's going to be a bother getting them in here too, but should work then. Yeah, one of the questions also was how are the RS485 chips are going to, handle having their termination removed or engaged and turned on and off and floating and stuff like that. But I'm using some higher quality RS485 receivers, and they seem to be okay with that so far. So currently it's connected to a DIG quad over here, but it's basically just providing 4 data connections to this sender 4 board, and that it has a single RJ45 port, which goes into this midpoint 1, which then strips off one of the channels, and the other 3 channels are continuing on this output port, which we're going to connect in a second. Oh, this is the wrong type of connector plugs. I'm going to try and bodge it. Let me turn off that power supply real quick. Let's see if we can bodge it. That. Yeah, that's not gonna work. I need to. I guess I just need to put some stuff on there. I need to fix this cable real quick. Hold on. Yeah, so there will be multiple types of boards. This is a sender 4, so it can send up to 4 signals. But you can send only 1 if you only need 1. And there will also be a sender 1 to just have a 1-to-1 system, basically. Now, this is going to be interesting. I don't know. I don't want to get all my forks out. So let's hope these random forks fit. Let's see here. Do they fit on here? Yes. Then do they fit on here? Good enough. I will take it. Hello. Well, you still can core count. It's still an option. I mean, if you run Ethernet up there, in theory, it's just as good, and it's likely cheaper than having to have a dig quad and this differential stuff. But if you want to make 4 boxes or 4 props, and they're kind of separated, well, this might be really interesting. Okay. Yes, Cyril. So there's 4 switches on here, and each switch represents a pair, and that pair you activate will get stripped off on that board, and all the other pairs are going to be sent along on the output port. And I'll show you that in a minute, because I now can hook up this power supply. You can use a dig to go with a PD charger, that's fine. As long as it's a USB power supply that can preferably deliver up to 3 amps at 5 volts, then you're fine. Let me fix this. Right, so I'm just going to put this on here. So now we have the first board, and we're going to take another 25 meters. There we go. Bam. So this is another roll of 25 meters. And once this all works, we'll step it up to like 100 meters or something like that. And we're going to put this in the output port, like that. And we're going to put it on the input port on this board. And now I need some 5 volt LED strip. Yep. Whee. And let's connect that up. I'm gonna zoom it out a little bit, because we need more space. Okay, so this is the second one, and we haven't activated a channel yet. Let's plug it in. Hope it doesn't explode, because we didn't test this one yet. Okay, so let me get this better, more over here. So the first one is working because we selected the first channel basically, but this one isn't doing anything yet because all the channels are turned off. Now, if I turn on the first channel, nothing happens because this board is stripping off the first channel. So this board isn't getting the first channel anymore. So let's turn that off again and turn on the second channel. Voila! That seems to be working fine again. Oh, this is actually less LEDs? I don't know. So now we have a midpoint 1 stripping off channel 1 and a second midpoint 1 stripping off channel 2. And this is 25 plus 25 meters, so by the time this board gets the signal, it's already 50 meters further away. So let's continue that, but let's step it up. Because one of the things I kind of want to do today is see when it breaks. Yeah, so this is a sender 4. So this is taking in 4 data signals and outputting it on, I don't know if there's actually a delay or because it's 400 LEDs and not LEDs changing all at the same time. We'll check that after we're doing a few hundred meters of cable, because this is 50 meters of cable, not 24, not 25. So I need to dig something out here. This guy. So this is going to be problematic. Okay. So let's hook up 50 meters to the output of the second midpoint 1 and to the input of this midpoint 2. Now this is a midpoint 2 because it can extract 2 channels if you want to. You don't have to. And it has power distribution and fusing. It's a, if you need to do more 5-volt stuff at that location or something like that, it's a more expansive board for that. Now this is being fed with 24 volts, so I also wanted to highlight that you can actually mix and match, because this board is getting so the sender 4 is getting 12 volts, this one's getting 5 volt, this one's getting 5 volt, this one's getting 24 volt. So let's connect that. Let's just gonna turn off all the channels. Connect this in here. For some reason it's white, but I believe that's the LED strip doing that. And let's give it channel 3. Okay, so now we have sender 4 going through 25 meters into midpoint 1, stripping off channel 1, going through 25 meters into midpoint 2, stripping off channel 2, going through 50 meters, and then going into a 24 volt fed board, doing another, so we're doing 100 meters in total. This will work with any WLED install. This is completely seamless for WLED. It doesn't know this is going on at all. Yeah, we can get the length because it's twisted pair and we're using RS485 instead of single-ended data signals. Now let's go over the top, and because I have another sender or a midpoint 2 here, and let's get 100 meters of cable. So that's this guy. So I can't see the chat anymore because all the cable is in the way. Hold on, there. Okay, so let's get this guy. Okay, and connect it to the first midpoint 2. So that's the third board, and the other side, if I could find it, I think it's here, to the import of the fourth board. Let's turn these all off. Okay, these are all off. Input. And I have another 24 volt LED strip because this is also being fed by 24 volt because that's just the power supplies I have on my desk right now. We're using 3 power supplies. Okay, so that's connected. And now I enable port 4. Aw, nothing happens. Why not? Oh, I know why nothing happens. On the midpoint 2 receivers, you have 2 ports that are connected to data 1, and you have 2 ports that are connected to data output 2. And 1 and 3 are connected to data 1, and 2 and 4 are connected to 2. Now, I'm not sure about that division yet. I might want to change that, but I'm not sure yet. But let's disconnect this and put it in the other data output. Yeah, but Grid Friday, if you can link me to a compact size 4-way toggle that toggles 2 pins at the same time for each connection and reconnects all the pins that are not connected, let me know. There we go. Okay. So now let me run you through it one more time. We have a sender 4. That's this guy over here. Let me turn off WLED. Sender 4 that goes into 25 meters of UTP cable. That goes into a midpoint 1 over here. That strips off 1 channel to this LED strip over here. Then it goes to another 25 meters of UTP cable. That goes into this midpoint 1 again, but then the second one. That strips off, again, 1 channel. Both of these are running at 5 volt. Then it goes to 50 meters of cable to this midpoint 2 board. which strips off one channel in this case, but it can strip off two if you want, and it has power distribution and fusing, etc. But this is running at 24 volt. Then it goes through 100 meter of extra cable to another midpoint 2 board, which again strips off one channel running at 24 volt. And that seems to be working perfectly fine. Is it working without a fuse? No, if you see these things are auto reset fuses up to 60 volt. So I'm experimenting with both for multiple reasons. But these are basically the fuses on here, right? So that's why these don't have a fuse in there. Yeah, you can use any type of board. Can even be non-Quin LED. That's why I'm designing this as an external system first. It's just, you know, you can use any data signal. But I will be designing versions for in the Quin LED ecosystem, basically. But I wanted to have external versions first. This should work with any one-wire protocol up to a certain bit rate. So these LED signals are 800 kilohertz, and I'm using 10 megabit transceivers because you want a bit of overhead and timing, and there's reasons for that. Yeah, but you can use any one-wire signal in theory, as long as it's unidirectional, because this won't work bidirectionally, basically. There is no midpoint 4 or receiver 4. I thought about making one of those initially, but now that we have this linking system, the more boards I produce, the more expensive the board will be, because if I can sell more of a single version, it'll be less expensive to manufacture that version instead of having lots of versions that I need to manufacture that each get sold separately, a few instead of many of some boards. But if you buy two midpoint 2s, you have 4 channels. And you just link it with a little pigtail wire here, and that's fine. So then you just combine it in a box like that instead of having a 4-channel board. I don't think that's too big of a compromise, really. Buying 2 boards instead of 1 if I can have good pricing on the 1 board. Hello, Quindor. I do have a Dig Octa stack. Can I have these boards for my Dig Octa stack, please? Yes, I have. You know that, Andy. I have some plans to make a Dig Octa version, basically. Tom, yes, if you need all 4 channels at that single spot, I would put a Dig Quad in there directly and not bother with all of this. But if you need 1 or 2 channels at multiple spots, this can be a whole lot easier than putting controllers all over the place. I know what you want, Tecturl, but these are prototypes. Once they're more finished and going into production, I'll get you screw holes and things like that. So there was a question earlier by Andy, actually, if we could test latency. And as far as I can tell, let me turn down the brightness a bit. As far as I can tell, these are all working in unison, although this guy has 200 meters of UTP cable connected between the sender board and the receiver, basically, or the midpoint. Well, that's one of the things I wanted to try. I want to see when this breaks. So I do actually have couplers. So let's disconnect this guy. One of the funny things is if you disconnect it, it'll just stay what it was. Right? So it just won't receive it anymore. Let's get the let's get this guy. This is another 100 meters of cable. Okay, let's connect that somehow. I don't know how I'm doing this. Okay. Oh man. Okay, but now how do I I guess like that. So now this board, this section is getting fed with 300 meters of U2P cable. And, well, it seems to be doing fine. Now I do see some slow change in... Let me change this camera a little bit. There, you might be able to see the LEDs a bit better. This one is now slightly behind this one, it seems. But let me stop the effect. And start it again. But it's not really fair because they're running sequentially, not at the same time. So let me make some segments. So this is up to 100. Add a segment. This will be up to 200. Add a segment. This will be up to 300. And this will be up to 400. Let's see if that works. Solid. Nothing works. Okay. Oh, okay, the color order is wrong. That's fine. Well, doing this. There are different LED strips, so that might change it slightly, but let me do the color loop again. And now we're doing color loop on 4 segments, right? Poor. Problem is, these are 3 different types of LED strip, so it's a little bit hard to see. I think it's still slightly behind. Just slightly. Let me, Wait. I know. I need to get something real quick. Hold on. Anyone remember this box? This is another 150 meters of U2P cable. So, here we go. No, the cat isn't here. I don't know where he is. So, let me get another coupler. Okay, another coupler there. Okay, coupler in. I don't know, like that. And well, now we're gonna. If there's delay, this is another 1 in the 50 meters, but I doubt this will work. Wow, it works. Oh man, I don't know what to do. So this is 25 plus 25 is 50 plus 50 is 100 plus 100 is 200 plus 100 is 300 plus 150 is 450 meters. Yeah, this is 450 meters of cable, and even worse, this isn't 450 meters of cable directly. This is 450 meters of cable going through this board, going through this board, then going through this board, and then there's 350 meters of cable going through this board. So, I mean, well, we can extend it even more. Maybe. Okay. I have another 50 meters of cable, so we can make it 500 if I have another extension block. I think so. Okay. We're doing it. I have another 50 meters of cable, which should go in here. Okay. I'm afraid my desk is going to buckle because it's really heavy. Okay, let's put that in here. And then we take this part and put it in here. Yeah. So now it's 500 meters. No, the midpoints do not regenerate the signal. They basically are a clear pass-through from this port to this port, going through the switches, of course. But if the switches are in the down position, it's a pass-through, like so it just loops around. And if they're in the up position, it gets stripped off and fed through the RS485 signal, terminated through a level shifter, resistor, etc., etc. So there's no regeneration going on. From here to here is 500 meters of connections and cables, etc. Of course, I paid really close attention designing the board to have perfect differential impedance and blah blah blah, and you know. Yeah, but that's the thing, Emil. 1.2 kilometers at 100 kilobit. We're doing 800 kilohertz, so let's say that's 800 kilobit. Put a 1 meter patch cable in between a little break, always does. So the most I still have is 50 meters of cable, but do we really care? Sure, Torben. Well, I can do all in 4 segments. No, okay. Let's delete the segments then, I guess. Segment. 400. Okay. Yep. Strobe. Strobe. Well, can I strobe more often? There. Why is this in the way? Okay. I can't really tell a difference. Yeah, I think so. No, there's no boosting of the signal. That's actually a good question. Where's my thermal camera? Let's see how warm everything is getting. Maybe the transceiver that's driving it all is like, oh no, what's going on? Sure, core count. My oscilloscope would also probably be able to see the difference, but you know that's a different thing. Let me. Okay, so let's take a look at the transmitter board. Oh, let me fix my camera. There. So the hottest thing on the transmitter board is 55 degrees. That's kind of to be expected. That's no problem. But that's the transceivers themselves. And actually for the second channel, I believe. Yeah, actually the one for the second channel is the warmest. I don't know why. But they're all about the same temperature, about 55 degrees. Hey, Unexpected Maker is here. Yep, so the sender board is fine. Oh yeah, these boards are just stone cold. Yeah, this one doesn't care either. 30 degrees. 30 degrees, 32 degrees. So this one with 500 meters of cable. Oh, my hand is warmer. Yeah, board is stone cold. 32 degrees. No problem at all. Okay, cool. Yeah, I can't really show you what's on my desk here, but, well, you can see the tower, I guess. So let me explain once more for Unexpected Maker then. We have a sender... Oh, hold on. We have a sender board here, which sends 4 channels. That goes into this... Well, almost can't see it anymore. This midpoint 1 board, which strips off... You can select which channel you want to strip off, or which pair. Which strips off one of the channels and then sends it on to another cable. The first cable is 25 meters. The second cable that comes out to this second midpoint 1 board is also 25 meters. That strips off another channel. Then it goes through 50 meters of cable to this midpoint 2 board, which can strip off 2 channels, but we're just stripping off 1. And then it goes through 350 meters? No. It goes through 100 plus 100 plus 150 plus 50. Yeah, it goes to 400 meters, and we already had 100 meters before that in the other board, and then it goes into this board. And we did some strobe test to see if there's any lag there, because, you know... Yeah, exactly, Grid. I mean, if this is the amount of latency we see, yeah. This is just Cat5e. Normal, unshielded Cat5e. Yeah. And even better, this one's running at 12 volts, these are running at 5 volt, and these are running at 24 volt. But the whole setup supports up to 48 volts. Well, it's Ethernet cable or RJ45 or UTP untwisted pair. Or no, what? No, twisted pair. Unshielded twisted pair. There's no shielded cable in here. No, the midpoint boards are not boosting the signal. They're a straight pass-through. So if we take a look at this midpoint 2, the signal goes in here. Zoom in a little bit. So the signal goes in here, then it passes through these 4 dual pole switches, and I can select one of the pairs using the switches. If the pair is not selected, like so, then it's not getting the signal anymore, as you can see on this strip here. And they all get passed along, but if I flip a switch, that signal gets broken out, and it goes through through the RS-485 chip termination, level shifter, resistor, etc., etc. And yeah, so that way you can... You know, have one UTP cable, string it along 50 meters, have a breakout board there for 1 or 2 channels, string another 100 meter of UTP cable, and have another breakout board there, and string another 100 meters, and have another breakout board there, because you have 4 channels. And, well, this board can extract 1 channel, this can extract 2 channels. Well, yes. Whatever is coming out of the RS485 chip is being boosted to 5.1 volt for a data signal for the LEDs. Yes. No, Cat6 does not have shielding. Cat6a has shielding. So the only difference here is this is 400 something meter of Cat5e, AWG24, and then there's 100 meter of Cat5 or Cat6 unshielded, but it's Cat6 and it has AWG23 connectors or conductors. So it has a little bit thicker wire, but other than that, there's no shielding whatsoever. Yes, currently all these boards are being fed independently from their own power supplies. That's correct. So this is just for data transfer. I will do some experiments in the future to see what's realistic, because what I kind of want to do is I want to make a 55 volt system where you inject 55 volt at the sender part and then have a buck converter at the end taking in 55 or whatever it's left. Maybe it's 48, maybe it's 52, and down convert that to 5, 12, or 24 volt to make it usable for LEDs. Emil Bart, I'm using a enhanced ESD RS485 chip, which has also enhanced range, and it's a 10 megabit transceiver officially. But you can't use a 1 megabit transceiver for WS2811 or WX whatever signal. Although it's 800 kilohertz, because of the timing, you need a faster chip than a 1 or 2 megabit chip. So I'm using a 10 megabit chip. Yeah, the current system also enables me to have 5, 12, 24, or 48 volt on each of these midpoint receivers independently. Because these are 48 volt compatible. I don't have any 48 volt addressable LED strip. But these current versions, all of them already work with 48 volt. But as I said, I don't have any 48 volt addressable LED strips. So it's kind of a moot point, but you know. Oh. Why am I using terminals on the side? I generally don't really like the plugging in from top. I guess if you build it in a case, sometimes it can make sense. But other than that, I enjoy the feed-through design better in that sense. Now, this is kind of something I don't like to do, because this is now a 3-sided board, and this is 2. Yeah. Oh, well, yeah, so these midpoint ones I altered to have a buck converter integration function if you wanted to. We've already been going 3 hours. I guess we could go a little bit more. Well, this works, right? We've kind of established this works. Let's do an effect. Who knows, maybe a real effect doesn't really work. Where is my... that works. I need to find a good effect. Oh right, the color orders are all wrong. I was like, why are the colors all wrong? Let me fix that. I think it needs to be GRB. No. It needs to be BRG? I don't remember. I don't remember which colors it should be. Oh, I'm not on the right effect. Jesus. There. Okay, that looks better. I guess not on camera, but... What do you hope to... When do you hope to have these available for sale? Do you have any target price yet? I'm hoping to get them out maybe somewhere in October-ish or so. I don't know yet. So far, testing has been good. So, kind of depends on that. So, I'm not sure yet. Pricing, I'm also not fully sure yet. There will be some different versions. Like, I want to make a version available that's like this. So, this is a very simple one-port sender and a one-port receiver. And that will, of course, be cheaper than a 4-port sender and midpoints and things like that. But as of most of my stuff, I'll try and price it competitively. Yeah. So I'm thinking, do we want to try and send power over it? I guess. I'm trying to figure out how I'm going to do that. First, I'm going to break this down. Because my desk is a giant mess. So let's turn this all off. Okay. There. Let's disconnect everything. Blow it up, magic smoke time. Well, I'm feeling somewhat energetic still, so we're going to experiment with 55 volts. That's always good, right? 55 volts is a very safe voltage. Yeah, but this is just to help for all those situations where it just needs to be a little bit longer, it needs to go further away, you're having flickering issues, data issues, etc. And there's no way for you to run the cable differently or whatever else. That's fine, just string along a UTP cable, get the sender one combo, and then you'll have a perfect data signal even if you have to go 100 meters. Okay. Okay. Let's disconnect all this. So, 50 meters. Let's get that out of the way. Oh, 100 meters. Just to show you this is real, this is a full spool of 100 meters. I didn't even unroll it. Okay. Oh, right. This is already disconnected this one. Here is a box. Here's a box that was in between there too, with 150 meters in it. I showed that in the last live stream. So we have some more here. This is 50 meters. And now we have 25 meters again. And this is, oh sorry, that was 50 meters. This is 25. And this is also 25. Here's a box, yeah. I don't know, man. Okay, so I kind of need to figure this out. But I bought some, before I actually built this, right? Let's get all this stuff out of the way. I don't need this power supply anymore. So what I have here, let me remove WLED. I wanted to be able to experiment with this. Thanks, Core Count. And these are RJ45 to screw terminals. They're actually pluggable terminals. Well, pretty cool. Just got these from AliExpress. They'll be in a Quinn box at some point. And I got two versions. The you know, the plug-in and the non-plug-in. And what we're going to do, and this is totally safe, is we're going to hook this up. Do I want to risk this board? Why not? Why not? Okay. We're going to hook this up like so. Okay. And then we're going to take out the data wires. But I don't know which ones are which. We're going to do some continuity testing. No. It'll be a Quinbox next week, I think. We're going to do some continuity testing, which pairs go where. And then we're going to take out the signal. But we're going to insert the signal again into here. Yeah, I'll beep them out. And we're going to insert them again into here. But then 3 of the other pairs, we're going to put 55 volt on. And then on the other side, we're going to extract those again. And we're going to take out the power wires and feed it into the buck converter wires in this guy. And then have a buck converter hanging off of here. And have the data signal here. So it'll be like this. And there will be UTP cable here. There will be power going in here. And we're extracting it here and looping it into there. Now this has to be the safest, most sane setup to do at the end of a live stream, because I'm not tired at all. Just connect color to color. These things don't have a color. So yeah. So this board will now have no power supply connected to it. And we'll have the power injected into here. And of course, in the end, I'll design a PCB solution for that. But yeah. So we first need to beep out. I need to turn on my multimeter. Oh. That wasn't the right plug. This is. Get more caffeine first. I still have a Coke here. Let's get some Coke. Ah, yes, some Coke. Well, this is as jank as it gets. So, I mean, I don't know if we're going to see smoke, but it's going to be interesting. Easy DMM, let's go. Boom. Okay, we should have a multimeter display in... Oh, no, I can't minimize that. Hold on. There. We have a multimeter display. Let's do some... Oh, and the continuity mode. There, beam. Okay, let's test that. Well, I guess you can also hear the beeps, huh? Why do my leads have, like, resistance? That's odd. Okay, whatever. So... I first need to know which chip this is. Well, one side of the pair... Oh wow, this is gonna suck. One side of the pair should be here. Wait, let me put it in the terminal. Okay, yeah, this connects to what I thought it would. So... If we take a look here, we have 4 RS485 transceivers. They're all in send mode. And I have it in this first pin here. And that corresponds to this pin. So then this one shouldn't be beeping. And this one should. But then how many? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. Okay. So we can use, but is this data 1? I don't know. How do I know? I think it's this pin. Yes. Okay. So the top transceiver here is linked to data 1. Yes. Good. Okay. Okay. That means first, but then should I do it like that? Because otherwise I'm going to mix pairs. Does it matter? No, it doesn't matter. Because does it matter? I'm confused. If this is upside down, which pair is it going over? I don't know. Because if we extract... Well, we're going to do it this way anyway. So it doesn't really matter which pair is what over here. As long as we beep it out and then feed it into these two again. Yes, that's correct, I think. Yes. Okay, so let's make this first. I need some 2-wire cable, I guess. Yeah, crossed or straight, that's a good question too. I'm just gonna get some random cable here. I know it's not twisted, but you know, in this case it doesn't matter too much. Well, it does matter a little bit, but these are too small. Oh no, my bit's gone. Nope. Yes. So, I know. Don't worry about it. I should really put ferrules on here, but we're not going to. Yeah, this is gonna mess with the impedance of the signal big time, but who cares? Who cares, right? So, if these are like that, I'm gonna put these in the other order. Because we twisted the block, so... Oh wait, I have to open these first. Do I? Yes. Well, the music has become appropriate. Let's hype it up. Oh wait, you can't really see much, can you? Sorry. You need alcohol for this. I almost need alcohol for this. This is such a bad plan. There's so many steps to mess up, and I'm tired, so I don't really want to verify every step. I mean, if it blows up, I can just build more, but... Right, so in theory, this is the data signal. Okay, so let's test that. So let's say over here is... I think it should be this pin. No. Oh, it's this one now. Okay. Oh, no, that's correct. Okay, yeah. Okay, I think that's fine. I think that's fine. It's fine. We don't connect power to this one. We connect power to this one. So let's take the output of my bench supply, which is also supplying my board. No, we can't do that. Okay, we need to disconnect the board supply. because we need the bench supply to send like 55 volts. You know, the safe voltage. Okay, oh, yeah. And then we take 24 volts, that's fine, from this board. So, come here, yep. And we put that into the dig quad. Is anyone still here? Okay, so now we have 24 volts into the dig quad. So that means the sender 4 is also getting 24 volt, which is fine. It can do up to 48. So that'll generate the differential data signal. And that'll go into here, which we need to extract on the other side. So let's do that first, so I don't get confused. I need some more 2-wire. Do I have some 2-wire on my desk? Nope. Oh, I have some. Oh, okay. Hold on. You're still awake. Nice. I just need some simple wire. There. This is good. This is good. We're gonna need more of that. Oh, this is better. Yes. Yes. We need these. Nice. Yes. Good. Okay. Okay. So we're gonna use this short piece here, and then we'll use this for something else. No, because I'm looking at these blocks in reverse, so that's why I'm flipping the signal, and I flip it back on the other side. So if we look at this block, and we look at this block, we take red and black. This is a totally different cable diameter. It doesn't matter at all. Right? So we put in here. So on this side I do it the same as on this one. I'm so gonna blow up my transceiver, that's fine. So now it's like this. No, that's wrong. No, bad, stop. I know, you shouldn't twist cables, I don't care. There. And now, over this side, we take this guy, like that, and we twist it so that red goes to the second one. So I need to open these. No, there are no numbers on there, just pluses and minuses, which sucks. No, I think this is right. Hold on just a second. Okay, I need to screw that in first. Come on. I know there's a thing called ferrules, but we're you know, hacking this up. And to make it extra jank, we're doing it without ferrules. So, over here, we go black, red, then we go red, black, then we go red, black, black, red. And it's coming in the same terminals it came out of. So that should be a pair. Can we agree on that? So in theory, I should now be able to beep. No, I need the UTP cable. Oh man, okay, let's get this cable here. Yeah, we've moved way beyond ferrules at this point. Where we were going, we don't need no ferrules, boy. Okay, so now I should be able to beep the transceiver points. So let's enable channel 1 on this one, there. And I should be able to beep the transceivers, because this is now all connected, in theory. So, top of the resistor here. No. Open, okay. Oh wait, this has 2 open, no. Huh. Okay, let's enable all pairs. Wait, maybe I messed up the pairs. The third one is wrong. Don't hold your breath. How is this wrong? So, red. Red, okay. Oh, you're right. Huh? But if it goes in here, oh no. I'm such an idiot. Okay, you're right, you're right. Okay, I'm gonna change it on this side because the wires are smaller. You're right, who said that? Who said that? Vexed. Thanks, Vexed. So, if they be facing the same way, red should be on the furthest one. Okay, okay. beeping the termination resistor on this side. Wait, hold on. I need to enable the right channel here. Disable this one. Nothing. So let's check these again. Red. Yes. Okay. So then red here is connected. Black here, connected. Red here, not connected because it's probably in pair 4 then, not pair 1. Let's enable pair 4. Yes. Okay, so we need to enable pair 4. That's fine. I messed something up. Of course, I did the same thing. The problem is we're looking at it mirrored. So each time I did the same thing, I did it mirrored. Sorry, I just now got that. So we need to put them all perpendicular. Like so. And then we see our problem. That this isn't the same. So I need to move these to there, and then we're on pair 1. Let's do that just to make sure. Then I know everything's right. Yeah, let's check crossing real quick. So on these, we're going black from outer to inner, and then from here we're going from inner to, well, it should be outer, so let's do that. Outer. Could this music get any more epic? Andromeda. Yeah. Nope. This is so janky without ferrules. I don't even want to know. Hi? Weer weer. Ja, ze willen jou zien, Kitty. Hey, kom eens. Kom. Ja, kom eens hier. Dan ga je wel oppakken. Hey? Is it okay? No, he doesn't want to be grabbed. It's like, nope, I'm out. Okay, let me try. Kitty. Oh, hold on. Kitty, where are you? Kitty? I can't show him. And my cables aren't longer, so Kitty, hey. There, you see him? Where? Okay. Kittytje. There he is. Hey. Yeah. Who's a good boy? Okay. Oh, my cable just won't reach. Sorry. Goeie jongen, hè? Joh. He's like... Okay, I think I just screwed it all in. I don't remember. So let's beep it out again. I think this one should be over here. No, this one. Oh no, I didn't enable the channel. There. I just want to check it like this. Yes. Okay, that is correct. That is now correct. So the thing we need to do now is we need to put in power here and then extract power over here. Right? So this is just a scientific experiment. Oh, it's all kitty talk now. How am I going to do that? Let's get some Wagos. No, not those. Sure, I guess this will do. Let's get one of the... Oh, we need two of these. Oh man, where are they? Okay. There, fine. Two of these. And I just got some little cables I still had here. Let's rip those apart. Let's make this just as long. On the other side, I'm going to use this cable. It's 55 volt. This short piece of cable is not going to matter. Okay. Yeah, that's the idea. I think with 3 pairs we could maybe transfer about 2 amps over, combined. And 2 amps at 55 volt is 110 watt, but not all of that will survive. So let's say we lose 5 or 10 watts or volts, and that's fine. Because we're using a buck converter on the other end, we still get a stable 5 or 12 or 24 volt. And because the voltage is so high, we're using relatively quite thin cable. Wire nuts? I've never used wire nuts in my life. Why would I use a wire nut when I have a Wago? I wouldn't know what to do without an automatic wire stripper. Oh wait, I should have probably stripped them longer for the Wago, huh? Well, we'll see. No, that should be okay, I think. Can you do a time lapse? Yeah, I wish. There's a place I can trace every line of me. I can taste every inch of the space I step into. Am I free? Sometimes I feel like I'm floating. Sometimes I feel something deep down. Okay, so kind of like that. Okay. Problem is, the other side looks like this currently. That's not working. But I should have some here that I can abuse. Okay, but do these go in here and make contact? No, because the stupid ferrule. Okay. Well, I don't want to sacrifice the other cable, so we'll sacrifice this cable. There, so that's kind of the idea. We'll connect that to my bench power supply. If I can get these off. Okay, so this needs to go. Black, oh no, these are too small. Well, I'll make it fit. The forks I have on this cable are kind of too small, but I think it'll fit. What? You just had a blue screen? It was like your computer not comprehending what I was even doing. Like, has he gone mad? Okay, so now we have this mess, which needs to go into this block. But now I need your intelligence, because mine is starting to fail. Which positions does it go into? Although this does have... Oh, this doesn't have? No, this one doesn't have it. These have plus and minus on them. But in theory, you know, it's pair, pair, pair. Do we just want to alternate plus and minus so that each pair has a plus and minus? I think that's probably the best approach, right? Oh, these are already open, I guess. Okay, so we start with plus. No, we don't need ferrules right now. These go into the terminals really nicely. There. Well, electrically it might matter, because you kind of want to combine plus and minus on a single pair. Crosslink from Magic Smoke, yes. But we're going to use my my bench power supply, which can current limit. Hey? I know you guys always looking for the next Magic Smoke, but current limiting is cheating! Oh no. Okay, so now we have 55... Oh no, my monitor's going to sleep, Jesus. Okay. We have 55 volt coming here. We're splitting that into 3. It's going into this block, going into the UTP cable. And then, in theory, it comes out on this side. So, in theory, we hook it up exactly the same. And then we're going to beep it up. Oh no, I didn't open these. So, first of all, the official stream topic this week was long distance data signaling. And we got up to 500 meters, and then I ran out of cable again. So that worked fine. And now we're going to try and put some power through there too. But we're doing it the most jank way possible. And the fun thing is, in theory, this will actually work even though you have some decent power requirements. Because this could transfer like up to like 100 watt. But that's why we're building this janky ultra contraption. Maybe I should print a sticker, ultra jank. Safety third, yes, more voltage. There's a little bit of copper sticking out there, nobody cares. If I make one mistake here, that's going to be bad. If I am going to build this, there's going to be like fuses upon fuses on fuses linked through a fuse. This is so bad. It's like fuses with an E fuse and a current limiter, and yeah, I can see those differential chips going poof too. Luckily, I have more. Differential chips like, and it's gone. Yes, this is 24 gauge UTP cable. Okay, we're almost there. I can see like all the copper on this guy. It's fine. It's like supposed to be like that. So now it's like that. Let's beep that out. In theory, I should now be able to do this and this. 1 point something ohms. Okay. Okay. Yes, there seems to be enough separation between positive and negative. So now it's just open. Before it probably had a capacitor somewhere. And now negative. Yes. Okay. So now let's check if this is linked to here somehow. It's not. And if this is linked to here somehow, it's not. Okay. Oh, we need another piece of wire. Let's take this wire here. This looks like great wire. Because this goes in here. And then these go in here. This isn't complicated at all. This is, you know, the most basic, easy setup. Everyone can do this. So this should be ground, I think, and this should be positive. So this midpoint 1 board, I have prepared to accept a buck converter. So if you use these terminals here as the input terminals, we then get some more stuff that still needs to go through Quinbox. But we get some buck converters, and this one is 48 volt to 12. Let's get something to 5, I guess. This is 24. Yes. 36 to 48 volts, but I know these are 60 volt compatible, I believe. Close enough. And 5 volt, 15 amp output. Good. Yeah. The midpoint board, I have prepared to sacrifice its life. Well, I have 100 meter of UTP cable. We can easily try that. And we actually have measurement points now. That's good too. That's easy. How do I open this? I know. By poking it with a screwdriver. Okay. So, can anyone look up if these are actually 55 volt compatible? I think so. Let's see. Input is red. Yeah, okay. I don't know if this is the longest live, but we're coming up to 4 hours. I'm going to sleep so well after this. Right, okay, so we need this. As I said, I prepared these boards to accept a buck converter like this, because I knew I couldn't stop myself from experimenting with it. Oh. Hey, there's still 65 people here. That's nice. Yeah, I thought they said 65 volts. Let me check if that's the one I have. I think so. Oh, well, this is from a different shop, but it's kind of the same thing. So as I mentioned, I prepared these boards with a buck converter in mind. That's too bad, Rob. We're almost there. So we have positive and negative going in here. Then positive comes out of here, goes through the buck converter, goes in here. Then it goes through the fuse. And then it does all the other stuff. Right. So this is connected to 24 volt. Which I believe is this power supply. Oh, do we need to beep more? Okay, 5 volt strip. I'm really tired. 5 volt strip. Okay, 25 meters. Sorry, this is a bit of a mess. This isn't longer. Okay. Well, this is an island and this is an island. Okay. All right. Safety glasses on! Yes! Okay, now let's turn this on. Let's turn this on. Okay. Okay. Oh no, the 5 volt power supply went on, so that's the wrong plug. Okay. Hold on. Zoom out more? I can't, because then you'll see my plank. Okay, so the mess with power is we have the UTP cable coming in. We split off the data signal, which is totally sticking out and not a problem at all. And then we take out all the other pairs of plus and minus. We feed that through this block, which combines it to plus and minus. And then we feed that into the board, and the board feeds it into the buck converter. And the buck converter feeds it back into the board, through the fuse, to the output terminals, to the LEDs. Yes. Okay, my 24 volt power supply is on, so the dig quad is on, in theory. Let's refresh that. Yes, dig quad is on. The differential sender board is on, so that is now outputting into here, going through the OTP cable, and then coming into here again through this block. Maybe. But this doesn't have power yet, because my bench power supply isn't on yet. Yeah. Okay, I'm turning WLED off again. Let me check something real quick. Okay, bench power supply, 48 volts. And I'm limiting it to a 0.5 amp. Okay, I'm sorry. I just have to do it. On. Why is it purple? Oh, the color order is wrong. Hold on. Nope, still wrong. Okay. Okay, so now we can measure. I need to go to another application. First try. And even while I'm tired. So we have 48 volts. Yeah, you can't really see with the LED strip here, huh? 48 volts going in. And we have 47.73 volts at the end. That's not bad. But we're only drawing 0.14 amps. So let's fix that. Let's fix that. Let's go here. Minus 300. Go. Okay, now let's raise the amp limit to 4. No, 2. No, not 42. Oh no. 2. There. Yeah, that's how it often goes split, but no problem. I like sharing, so. So let's raise the brightness. So now we're drawing 0.36 amps, but that is 17 watts. So we have 47.9 still going in. And on the other end, we have 47.36. So we're losing a little bit of voltage here. 47.9. 47.36. That's not too bad. So let's go white. Yeah, that's the max I can do, I guess. Huh. Well, we can try double feeding it. So now we're drawing 25 watts. So we still have 47.97 here, but on the other end we have 47.11. So we're losing 0.8 volt. That's not too bad actually for 25 meters. Where's my thermal camera? Okay. Well, likely the LED strip is going to be the hottest in this equation. Oh, it's actually the PTC. It's a 5 amp PTC, but that is currently 45 degrees. And the LED strip, 55. Let's see over here. This is again around 50 degrees. That's normal. This guy, well, the PTC is hot, but that's also normal. The cable? No, the cable is stone cold. Cable's not even showing up. Nice, Mark. Share it on the Discord. Always love to see. So I'm going to turn this off real quick. And I'm going to take one of those wrong plugs I had on this side. Of course, now I can't find them. Here. No. No. What? I just had so many wrong plugs and now I can't find them? That's always how it goes. Yeah. How is that even possible? I just had 2 of the wrong side plugs, which I now need. And now they're gone. What the actual... I can't find them. Ah, have it. Got it. This will be pre-assembled only. that this isn't something you want to be building yourself. So I'm going to add some wires to the output. So basically we can... oh, we don't need data double. There. So basically we can double it up, double the power output. Because that's how 5-volt LED strip works. It has massive drop. You know, we were sending about 25 watts, and a single injection point will do about 4 amps. So at 5 volt, you do the math. Okay, so now we're connecting this side to the back side of the LED strip. So now we should be able to draw about 8 amps. Okay. This will get hot, but we're not caring today. Power. Oh, wow, okay. We're immediately going... It was still set. We're now drawing 0.9 amps, so 43 watts. Okay, I guess I could take this off now. That'll create some voltage drop there. So we're still putting in... Oh. What? Oh yeah, no, that's correct. 47.96 we're putting in. And we're getting out of the UTP cable 46.4. So we're dropping about 1.5 volt, something like that. I guess we can measure over here too. Yeah, 46.4. But the buck converter doesn't care, because even if it got in 40 volts or 35 volts, it would still make a perfect 5.10 volts output, because it doesn't care about that drop. That's the whole idea. Now this will get nice and toasty. But let's see if we can see some of that drop, because... Oh, we're only doing 40 watts still. Not sure why. Is something getting warm? No, the cable is still black. Converter's almost black. Cable... LED strips nicely and warm. Nice and... Oh, wait. Oh, that's going on. Remember I had a 5 amp PTC on here? Yeah, the PTC is 95 degrees. So that's our limiting factor. In a second or two, the PTC will start limiting completely, and then it'll just... Yeah, we're at 38 watts now. 37 watts. But I can put another one on. Yeah, 35 watts. Okay, that's not useful. So let me solder on another one so we can actually draw 10 amps. Spacing is a bit tight on this one. Oh no. Didn't mean to do that. Sure, let's do it like that. There's too much cable here for it to stay put. There. Put something heavy on it. Okay, let me solder that up real quick. Let me turn this off. There we go. let me. There, all done. Nice and smoky. Because these are all custom footprints I designed, so it's modular in how many PTCs I can add for a single channel, blah blah blah. I don't remember how this went. I think something like this. Okay, so now we have two PTCs that can each do 5 amp, so we should have 10 amp capability now. Which is exactly right for a midpoint or dual injection. Let me remove my solder wire. There. Power. Oh, it's a bench power supply. Hold on. Go. Okay, we're at 0.3 amps, but the controller reset, of course, because I turned it off. So let's go full orange. It's nice and diffused, or nice and even now. And we're at 0.5 amps. And let's go white. There we go. Yeah, we're drawing 45 watts again, or 0.93 amps. 45 watts going in is likely about... well, I guess we can measure that. It's likely about 8 amps coming out. So let's clamp that. I guess we need the... No, do we need the orange one? I think so. Yeah. We're measuring 7.8-ish amps going from the buck converter into the board, which then goes into the LED strip. Yeah, this basically works, I guess. Let's see if any connection is getting warm. It's only an amp. I mean, it's 0.9 amp. Yeah, this is not even showing up. And the UTP cable isn't showing. 27 degrees, maybe. You can see the cable's slightly colored differently than the table, but it's basically not showing up. Probably the wire from the buck converter is warmest. Yeah, that's 33 degrees, because that's about 8 amps. But then there's only 1 amp going in. The LED strip, though, is, you know, nice and toasty. You can actually see the effect of voltage drop, because now you see a hot ring over here, and you see a hot ring, I guess I should turn it around, over on the outside and on the inside. That's because voltage is coming in here and then dropping, 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 but voltage is also coming in here and then dropping, dropping, dropping. So the voltage is actually the lowest in the middle, and it's higher on the outside edges. That's why I always say, if you want to fully power a 5 meter, 60 LEDs a meter, 5 volt WS2812B strip, you need to triple inject. You need a front, end, plus middle. And currently we only have front plus end. So, yeah. But now the fuses should be fine. The fuses are 60 and 60-ish. Yeah, 61 and 63 degrees. That's fine. That's normal for these PTCs. So yeah. That works. Cool. Can we do effects? Let's do some Paletti. Also make the LED strip less warm. So that's 21 watts and 45 amps. Now, We're already going 4 hours and 15 minutes. I'm almost done. But we're going to do one thing. One thing is left. We're going to disconnect this cable while it's running, because that's the smart thing to do. And then we're going to get this. This is 100 meter instead of 25 meter. Okay. Now we're gonna get some voltage drop in here. I think. Should. Okay. Still works. Still works. That's awesome. This is such a janky mess. Okay, so we have 47.96 going in. Okay. And we have 44.7 coming out. So we're losing 46 to 2.5 volts. That's actually not too bad. Oh, we're only doing half an amp. Hold on. That's not fair. There. Now 1.02 amps is going in, 48 watts, and we're only getting 41.1 volts at the end. So now we're dropping a good 6.8 volts. Something like that. Yeah, now we're dropping a lot of voltage. But the whole reason this works is because we've got the buck converter at the end, and it doesn't care if it gets 36, 40, 48, 50 volts. It can make it all into a stable 5 volts. So even though we're dropping a lot, that's inefficient, and it's being translated into heat, although this is a lot of cable to heat up. Because of the buck converter there, you get a perfectly stable, great output. Right? And if for doing effects, it uses a lot less. So, that kind of means the idea works. Although, I wouldn't advise anyone to build it like this. But I can likely build a PCB version of a 1-to-1, because it'll always be 1-to-1. It won't be 4-to-1, or 4 midpoint, whatever. So midpoints and stuff like that, that's all reserved for no power. But I can probably build a 1-to-1 pair where we have one data connection and then use the rest of the pairs for power. And then, just like this, have the buck converter easy hookup terminals like that. But then we don't need to feed power into here. It'll just come from the, the UTP connector or the RJ45 connector. And we can still fuse it and stuff like that. I'd fuse it on this side for the output power if the cable gets shorted. And I'd fuse it here for after the buck converter and blah, blah, blah. But yeah. What if you give it 55 volt? Well, it doesn't really change the equation, right? There's more volt, so we can potentially have more drop, but we'll have a bit less drop because it's less amps. But that's it. The end result is the same, because as long as we stay in range of the buck converter, it can do its thing, and it'll be fine. This is a reference connection video method. Yes, I'm going to edit this into a short tomorrow, and then I'll call it the UTP cable LED power how to connect video. And then I'll just say like, yeah, connect it like this, and it's awesome. It works great. No danger at all. But the fun thing is, if we run the LEDs a bit lower, because now, let's run them at this level. We're only drawing 0.23 amps, so that's 46.4, 47.9. Yeah. Oh yeah, PUE. Yes. All PUEs everywhere. So. Yeah. Remember, safety is our number 3 priority. Yeah, but that's just the thing why I never wanted to do anything with PoE. This already exceeds what you can get out of PoE double, if not triple fold. But with PoE, you need a lot of expensive equipment. And then you still need the buck converter and everything like that. 230 volts? Well, it'll probably be fine. Although you might get some arcing between some pins. Oh, man. Okay. Oh, no Coke. So, there's 53 people here. And I know people don't like to chat, so let's start a poll. Should I develop... Oh. Oh, well, we're at 92%, 93%, 94%. Because this would basically mean you can get a 50-meter UTP cable, get 2 boards, and a 55 or 48 volt power supply. And then you can run a 5 volt, 12 volt, or 24 volt strip 50 meters away, perfectly power injected, no problem. Quadro, yes. Voltage drop with 1 pair instead of 3. Okay, but that is going to be the last thing I do. Cable tie, well, just say yes. We're doing differential signaling for LEDs combined with high voltage power that we buck convert at the end. But then less janky like this than this. So... Rob de Graaf says, maybe you should try 1 pair. Okay. Okay. If I can disconnect this side. Yeah, I think that's safe. I'll fully disconnect it. Okay, I removed 2 of the positive wires. We still have the negative wires, but I don't care about those. Well, okay. I'll do it right. Sorry. Well, sure, I agree there, Cyril, but there have been demands and questions for this type of setup anyway. Okay, so now we only have, 2 wires left. So it's only going over 1 pair. But it's not even the same pair. Let's fix that. But there's a lot of people who have issues getting a power supply on the location where they want to run their LEDs. But maybe a little board and a buck converter is no problem, because they don't have a power outlet there, or they can't reach it anymore and stuff like that. So, okay. Beam. So, it's still doing what it was doing. We have 47.96 going in, and we have 42.9 coming out. Let's go to solid. And now we have 33.5. And now let's go full power. Uh-oh. Yeah, okay, we're only getting 17 volts at the end. So that's not going to work. Let's see how far we can push it. Okay, so now we still have 47.96 going in, but we only have 30 volts coming out of the other side. But the buck converter can still make it 5.11 volts. But once we drop below 30 volts, I don't believe the buck converter can still regulate it. So yeah, that's the limiting factor in this case. But you really do want the other pairs, right? Because yeah, now we can't go full power anymore. We're still drawing 40 watts, but if we take the clamp meter here, one moment. Let's see how many amps we're doing. Yeah, we're only doing 4.9 amps now, where before we were doing 8 without a problem. But if we go higher, the buck converter fails because it's just not getting enough voltage. Well, it's being dropped to heat, but it's not being dropped over a small area. It's being dropped in this giant spool of 100 meter cable. Right? So I can take my thermal camera. See, the thermal camera doesn't even register the cable, right? It's 30 degrees, is it? Nah. It's not even warm. I mean, this is where I touched it, so that's why it's warm. But otherwise... But, I mean, we're only talking like 10 watts, right? And 10 watts on a 5 centimeter or 10 centimeter piece, that's a lot of heat. But 10 watts on 100 meter of cable, although it's bunched up and everything, that's not too bad. End poll. Let's see what it says. 93% said, develop this. Yes. 6% said, no. 30 votes. What you're saying there, Talon, is partly true, but this is specifically Cat 5e with 24 gauge. But, well, I can't reach for it. I have some Cat 6, but Cat 6 specifications does not specify inductor diameter. But I specifically went out and bought some Cat 6 with a 23 gauge instead of 24 gauge like this. So I will be doing tests in the difference in that. So I bought it specifically for that, basically. But Cat 6 specifically does not specify conductor size. Just like Cat 7 can be 24 gauge or 23 gauge, or you can get some Cat 7A in 22 gauge, for instance. But yeah. 1% voted for Cat. Cat's gone. I don't know where he is. But this one, he likes to chat with people. So, but yeah, I will test 23 gauge cable versus 22 gauge cable. Although I have to tell you, crimping that 22 gauge cable was a real bitch. I mean, I hated doing that. That was I basically crimped 6 other cables 24 gauge in the same time I did one 23 gauge. It was stupid. But yeah, again, 100 meter with data on there and 48 volt running in the other pairs. That's also a thing I wanted to test. Seems to be working fine. Because, right, one is now the differential signal in one pair, and the other pairs, or they were, all power at 48 volts. So, you know, that could influence the signal, but seems that works fine, I guess. I'd have to scope it, but, you know. So far, it looks good. I like doing practical tests first, and then scoping it. I don't know why. Okay, we're never going to end this live stream. Let's, I'm going to finish my Coke, and then Hello from the middle of the USA. Hello there, David. You reached the end. The end of 4 hours and 30 minutes. Because more fun. Yeah, yeah. Thank you there, Tikiter. No, I make a different board for that because these systems wouldn't be compatible with each other because there'd be power running over those pairs. So I'd make a board with fuse protection and things like that on the sender side, and that'll also handle 48 volts. And then I'll make a board on the receiver side, which also has fuse protection and easy buck converter connecting, stuff like that. So you don't need the external connections. Yeah, thanks there, Fenatech. That was basically the idea, because I kind of figured the other stuff would work. It was the first test, but still. Especially at 500 meters. What the fuck? Well, sorry my English there, YouTube. But this power test, I needed all the other stuff for that first, which I now had. And then I thought, okay, let's do practical power tests before I actually develop the boards and stuff. But hey. Yeah, but Cat 8.1 is, I believe, it has to be PIMF. So it has a metal braid around it, then probably a metal foil. And then each pair is also in metal foil. And it has a stiffener inside, etc., etc. So that all makes the cable thicker. Then there's the twisting that it has, which determines how much megahertz it can reach. And there's all kinds of things that can make a cable thicker without getting a bigger or a larger diameter conductor. So you need to look at the you need to look at the box, what it says. And I specifically went with 24 gauge, which is the normal gauge for Cat 5e, Cat 6, etc. And then I have some 23 gauge as an extra test. And I looked at buying some 22 gauge, which you can get, but it was like $200 for a spool of 100 meters. Yeah, maybe at some other point. It's kind of expensive just to do one test. Thanks for this live, even if we didn't see smoke. There was a cat. Can a cat replace smoke? I think so. Always a great pleasure to see your videos or live. Thanks there, Cyril. You want to light 3 bars at MCH from a Dig Uno? Okay, just daisy chain them, Emil. Oh, cat exceeds smoke. Well, there you have it. And with that, my can is finished. And I bid you all farewell. Thanks for watching, guys, and sticking with me through all these shenanigans. Everything turned out great. That's always good. So I'll get back to developing. And as I mentioned, I'll be on vacation next week, but I'll probably have a Queen box ready. I have to see. And I'll catch you guys next time. Bye-bye.